the reason we're here today, interlinked organisms, um, which will be focusing on Blender and Grasshopper and Rhino, um, with Oscar. And Oscar is a member of Design Morphine, and like I mentioned, he's also teaching in the Masters and was a student and engineering lead at Pano, Pano Micron. Is that still correct? Um,
Yes.
and yeah, so Oscar is a computational and product designer. He holds a master's in computational advanced design from Zymorphine and a bachelor's in product design and technology from Loughborough University. He's driven by complex integrated problem solving, often in the intersection of hardware, software, and complex CAD, with the goal of creating physical products. Additionally, Oscar holds particular expertise in the field of manufacturing photographic equipment. He's currently pursuing contract work and teaching. So let me stop sharing here. And then so for all of you that are joining us today, if you have any questions, feel free to ask them in the chat or with the Q&A button. And after this webinar, it is being recorded, and then afterwards, once that recording is processed, you'll receive an email on how to view that webinar. So thank you, everybody, and we'll hand it over now to Oscar.
Okay, perfect. So let me start sharing my screen and then we can jump right in. Um, do that. Screen one, share. All right. Hopefully you can see my screen. That's all good.
Um, Not yet. It says started sharing screen, but hasn't come through yet.
Okay, let me know when it's
Actually, your camera is frozen, I think.
okay, that's interesting. Um, does seem to have frozen up. Always a good start. Yeah, it does seem like my screen and the sharing screen is frozen, but hopefully it will switch out. Are we good now? Your sharing screen.
Uh, Now,
I seem to be unfrozen now.
yes, now it's good. Yes, we see.
Okay.
Yeah, we see Blender. Yeah,
Okay, cool.
you might
So
want to like turn your. I mean, it's up to you, but maybe if you want to turn your camera off, save resources. I don't know. Up
oh,
to
just
you.
so yeah, yeah, okay. I can do
Yeah.
that. Video. Just so more bandwidth for
Yeah.
that. Okay, so I'm just gonna start. Basically, in this webinar, the main focus is going to be on modeling these organic forms in Blender, and then switching over to Grasshopper to do patterning, both for meshes, and then we'll understand how to do patterning on NURB surfaces, um, and sort of projecting curves onto them, and then how to make these things link with each other through some simulations at the end, and then go back to Blender for rendering. Um, if you're completely unfamiliar with Blender, so this is probably what you'll boot into as interface, or you might have something else like this with more tabs on the side. For now, we'll be mainly using the modeling tab. There are a bunch of options up here that you can use if you want. Um, I'm just going to press Control Space and on the space to be mainly focused into it because I won't really be using any of the other tabs for now. Um, this modeling exercise in the files that are shared with you, you have um, a couple of bodies in here. So these are just like if you feel like you're getting sort of behind or just want a model that you can use for the later stages if you don't like what you come up with during the stage on your own, you can use either of these models. So here's a model with sort of a secondary skin, and then there's a model here which is the model I used during the masters. And as you can see, if you press tab, you can go into edit mode. These are also available up here, so you can go object mode, edit mode, and tab allows you to switch between the modes quickly. And here you can go and edit the mesh if you want to just play on a mesh that exists already. But just in for the effort of learning how to do it, I'm going to start from scratch. So I'm gonna basically press Shift A and drop in a cube. You can also do go up into the menus here, and hopefully I actually have the toolbar from Zoom hiding my stuff. Up here you have the add, and you can add meshes, cubes, planes, or whatever type of geometry you prefer to work from. You could add a sphere. Usually it's a bit too much detail for what we're going to do. You could sort of reduce down and work from that if you wanted to. Go for like 3 and 4 or something, and have an interesting starting point. But the cube is probably the safest. So we have a cube. I'm going to press Tab to go into the edit mode. And from here, up here in Blender, you have your options. So you have selecting vertices, vertex mode. So you can select individual vertices and move them. You have your edge mode where you can go and grab these. So to move things, there's shortcuts in Blender. So G is a shortcut for grab. So you can press G and then you can move items around. And so you can do that with edges, with vertices, or with faces. And then so you have grab, you have R for rotate, S for scale, and those are your main ones. And all of these are also available here, this little menu here, which may or may not be there for you. If you press the shortcut T, it appears and disappears. So if you don't want these, you can T and hide them away, or you can bring them in. So next, what I'm going to do is I'm going to press 3 or press the face selection mode. And then I'm going to press E and extrude a face and maybe scale it down to start making sort of a shape. I think I'm going to do that twice. So select out, scale down, and grab these and start making a sort of spindly shape. I'm probably going to do this on this side as well. Extrude this out. And then extrude this and maybe give us 2 different directions. Maybe this face I want it to be a bit angled, so I can either press G and just grab it, or if you have a mouse with a middle mouse button, if you press that in, you can snap to different axes by just pressing it and moving in that direction, or you can press the axes. So X, Y, Z will allow you to snap to these axes. Another option is just to double tap G, and then will allow you to slide on whatever axis you're going towards. It's going to do that just to be able to sort of angle my faces. Do that. Probably scale it down a bit. Scale this down, make something like that. And I'm trying to work in as low of a polygon way as possible. If you wanted to, obviously you can, if you press A and to select everything, you can do things like right click and do subdivide, and then you'll get more geometry. But this quickly becomes very difficult to handle. And so it's nice to sort of work on it on a low poly fashion. A shortcut to get to a smoother look, if you want to be able to model things that look a bit more organic, if you hold down Control and press 2, you'll see we'll add here a subdivision modifier. So these are in the modifiers tab. There's a lot of tabs here, and we'll go through a couple of them during this webinar. And here you'll have a couple of options. So you can go up and down in the levels, and you have viewport and render. Render will only matter later, and so for now we can kind of just focus on the viewport. So if you want things to be smoother, you can go up, and if you want them to be less smooth, you can go down. A good balance, though, is often 2, and then if you right-click, you have the options for shading. And so here you can shade smooth, auto smooth, or flat. Smooth will just make everything to be smooth. Auto smooth will allow you to have, if you have some sharp edges, it will sort of render those as sharp edges, and flat is just what we have right now. So I'm going to pop it over to auto smooth so that I can have something that it already starts to look a bit more sort of rounded and natural. So now that we have this, just 2 little legs, what I'm going to do, I think, is I often think that it's nice to have some like pockets and holes. So I'm going to move this over, make a couple things, and then I'm going to use the gumball up here and start sort of modeling rotation. I want sort of a circle, because I think they look kind of nice. Do that. By the way, if you have any questions, obviously feel free to pop them in chat, or if there's something that I said that you didn't quite catch, you can always comment that as well. So now I have these two, and I kind of want to connect back here to loop it back around. So what I'm going to do is I'm going to select these two faces, holding down Shift, and then I'll press X, and then I have my delete options. So vertices, edges, faces, here on delete faces, delete two faces. And now if I want, I can bridge this back around. So I can select this point, select the other point, and then if I press M on the keyboard, I have the option to merge. So at center, at cursor, collapse, first, last. And here's the last. And that will give me the second point that I clicked, basically. If you selected like 10 points, it would merge towards the last one. But usually I'm just merging 1 and 2. You could also use, there's like weld tool, I think, that you could use to make this in a different way, but I like to use the merge tool. So merge all my way around. So now I have this kind of thing, which if I even go up one level, so we are starting to have one loop. I might even add a secondary loop after, but maybe I'll spin off in a different direction. I'm gonna grab one of these faces, probably like under here, and start extruding that out. And really just working my way around and trying to find some interesting shapes. I might actually, when I see this, maybe the circle looks a bit out of proportion. So what I'm going to do is I'm going to first press Alt and Z, and that will give me the X-ray mode. And so now basically when I select, it will go all the way through. If I didn't have this activated and I tried to select from the top, you would see that it doesn't really grab the bottom faces. So it's a bit nicer to be able to press Alt Z, connect everything, and then I'm probably just going to scale this down and move it in a bit just to make things a bit different in terms of proportion. Smaller. And then I'm going to keep kind of extending some stuff out, making a spindly little guy. You can also, if you wanted to select whole more edges, you could press Control and Shift and connect your edges. I pressed 2 to go over to the edge mode. And then I can sort of scale down maybe just the top section of this. And I think that I'm feeling this connection here is a bit boring, so I'm gonna extend it out to get a bit more interesting edge. And then soon what I'm going to do as well is I'm going to start creasing some edges. Now, what is creasing? Creasing is an option that if you're familiar with Rhino, you'll also have seen it, which allows you to basically just make these edges sharp, right? So if I select this edge and, for example, say here, my crease options in Blender are over in what's called the N panel, because if you press N, it goes away and comes back. And in the item, you have crease data, and you can drag the slider up, and you'll see that it tries to basically, just like if you had a piece of paper and you were bending it, it tries to put a crease on it so that it becomes sharp. And this is very useful if you're trying to model, because it allows you to sort of define these shapes without having to add geometry, right? This is quite a common approach in a lot of software. So like Maya will have this, Rhino does, almost all of the software that allow you to do a form of subdivision modeling, right? Will have creases to be able to allow you to define the shapes you're making a bit better. The problem is that it is not interoperable between these software at all, right? So the creasing is mainly like inside one piece of software. None of the formats really carry the information over from one to the other, which is really inconvenient. But that means that if you're using creases, you have to sort of use them in the software and then define them before exporting, if that makes sense. So I might take this face under here and start to scale it down and go off in a different direction to get sort of an interesting additional finger, maybe. I was going to go back over there, and then maybe I'll want. So maybe here, I'll change this crease so that I'm changing the edge flow, and instead of going there, I'm going to go downwards, and we get a nicer sort of loop. And the creases here really help you to sort of define what your look is, what you're looking to do, and how you want it to be shaped. And if you were doing this purely with modeling, it'd be a bit more difficult. Because you'd have to go back, and if you want to change things, you would have to remove geometry. So staying in sort of as low of a poly space as you can before committing is always good. Work like that. I think this is always very sort of personal. You can go back and forth here for ages, spend weeks on a specific shape. I'm going to try to not spend too much time on this and not think about it too hard. It's all an exercise after all. Do that. I'm going to crease up here, maybe extend it out so that I can get this roll, and then maybe crop it down maybe here in the bottom. So I'm going to go up to the top and go in. I think maybe that could be interesting. So you have this whole shape at the top. One of the things that I would recommend if you're a new Blender user as well is going to the preferences. And in the preferences, you have all of the sort of pre-installed add-ons that are already come with the software, but that aren't activated, right? Because they add a bunch of different tools that some people might not want. The two tools that I would recommend installing, you just have to check the button, is first of all, loop tools. So this comes with and gives you a bunch of options for modeling, and then node wrangler, which is down here, which will also come in handy, but a bit later. So if you activate loop tools, you should be able to go in. And here also, I'm going to go to subdivision and activate this on cage so I can see my lines a bit differently. I'm going to go in here, and I want this to appear more circular. So I can go in, and now if I right click, I'll have loop tools, and I can do circle. And now because I have the creases activated, it doesn't do a perfect circle, but you can see that it has sort of placed them. It's a pentagon, so it's not perfect, but it has placed them in the closest fit to a circle. Sometimes it does kind of like mess with the rotation of your elements. I'm going to rotate it back a tiny bit. But I think that is slightly better. So we're going to maybe do that and then let this edge flow down here around. And I'm really just trying to find some interesting bits. Maybe that clamps it a bit too much. So we might just go down to the edge over here and circle back around that way. Another way to add creases, by the way, if I select this one, you can do Shift E. And now if you drag, it will add the crease. So you don't have to go back to this menu every time. I just think it's nice sometimes to be able to drag sliders. Okay, so we're starting to build this out. I might move this over, move this down, and then so right now things are very, very sharp, and we'll basically soon be smoothing them out a bit. But it's interesting to try to keep some kind of interesting edge flow. I might add now, I feel like down this line, I want some more geometry. And so I can press Control R. And Control R basically tries to add a loop, right? And so sometimes that adds a loop that goes all over the shape, or sometimes it's just very local. So here I'm going to add a shape here. And I just want some more interest on this. So I might press Alt S, which allows you to scale along the normals, and I can scale this out a tiny bit. So I might even, I don't know if I like this curve here, so I might delete it. I might bring this down again to smooth it out. Or maybe not. Who knows? Keep this for now. So we have some liking of a shape with big mess in the center. I'm gonna start over on the creases. Sometimes you don't like what you did. But it's good. You can go back. What I am going to add instead is probably a secondary loop onto this. So I'm going to build out and make a secondary loop here and then add some flare to that. So I'm going to build this out. Not focusing too hard. I'm going to go back to seeing my cage so I can tell what I'm doing. Ooh. Okay. And so now, instead of joining it like I did before, I'm actually going to select these two faces and use loop tools and do bridge. And that does kind of the same thing as we did before with merging, but it just allows you to do it a bit quicker. And so I have the secondary loop. I am going to pick the internal one, circularize, and probably do that for the bottom loop as well. Before I start deforming this, I'll make it just a bit cleaner. But I'm not going to circularize the exterior because I want it to be sort of an odd shape. But what I am going to do is now I'm going to select the top and it allows me. Ooh, interesting, windows popping up. Thank you. Let's not do that. Probably just clicked. Okay, it's a good time to freeze up the software. Always welcome. Okay, I think my middle mouse stopped working, but we'll make do. Hopefully. Is anything wrong here? Let's try to. Okay. What is happening? For some reason, my controls have given up, except for the gumball, but my mouse is dead. Okay. I might actually just save for a second and reopen it. It seems like Blender has decided to stop liking me today, which happens sometimes. A little preview of all the mess we're gonna make later. Check if there are any chats as well. No questions for the moment. Yeah, if you have any questions, now's probably a good moment while I'm rebooting. Otherwise, I'll keep going in a second. Okay. Let's get this started. Okay, back in it. Now it's respond to my controls again. Okay, so as I was saying, I select these two. And now I'm going to do proportional editing. So if you press O or press the tag up here, you have the option to do proportional editing. So you have a bunch of different sort of what do they call them? I don't know. Like fall off types. Yeah. So you can select like basically how harsh or how smooth your proportional editing happens, which allows you to sort of move more stuff than only the bits that you selected, right? So I'm going to scale this down and maybe move it over. Um, and then what I'm going to do is I'm going to select this edge that I haven't made, and I'm probably going to scale. Ooh, turn off proportional editing once I've done that, and then scale this down. And I'm going to go back and start, I think, creasing things again once I have these guys. And I'm just going to check that, turn off my smooth here and check what I've done in terms of little bits. Make sure that they're not too convoluted, that my shape essentially isn't too out of line. Having panels of different sizes can help later when you're doing some patterning. It sort of makes your mesh a bit more interesting than if all the panels are exactly the same size. But it is very much sort of up to you how you manage the edge flow. Sometimes it can lead to more interesting results, or just doesn't really change anything. So I like to edit sometimes well in the Q view just to so I can see a bit more what's happening. I think maybe making this panel a bit longer could be interesting. And I'm going to basically add some bulbs here at the end and extend it back out. So maybe I can, it flattens down and then extends back out. Feels like sort of an organic plant thing. We have a little like balloon at the end. I don't really like the exact transition I've made here, but I don't think it's exactly terrible either. So we'll sort of stick with it. I think it's has some interest in it. But probably thin it out here on the side so it's not as flat. So you have both an interest in all of the axes. Often a bit of a trouble with these organic shapes is, you'll look at it from one axis and you think it looks nice, and then from the other one, you have a look and you think it's just kind of horrendous. But that is life sometimes. I'm going to get these. I'm actually just going to at the end here and do proportional editing again, so I can move. And with the scroll wheel, you can extend your range. So I can sort of move this in and extend to what I'm activating. Probably a bit too thin, isn't it? We'll make this guy. Yeah. So this sometimes is good to have the Q view active where you can see that like you've made some bits of it a bit out of proportion. Like that. And so now I am going to add some creasing back. So maybe this guy, and then go underneath to here. And I'm gonna try to make a loop that sort of self-terminates. Hopefully I can find one that I think is interesting and worthwhile in that sense. So that loops back around basically. So maybe I don't pick. Yeah, maybe I don't pick these two, but I instead go over one and around. And then maybe I'll cross up. And eventually I want to get back to somewhere around there, but I can come back to it from maybe the top, right? So let's do that. Let's, instead of going down, let's make this loop go up here and maybe just around to separate these two. We'll try something like that and see if it works. Is that what I want? We'll try it. Try it and see what happens. Probably actually go somewhere else. I can see somewhat of a wing, and then I get this sharp edge, and I can come back up here and around, and then instead I won't go over there, I'll go somewhere else. But yeah, so as you can see, I mean, you can spend really ages on any of these shapes. I'm going to try to not spend too much time on it, but the perfectionist in me wants to make something nice. Do that, move this down, and create some more interest on that edge. Really the point of this creasing is to be able to add some definition, which we're then going to sort of bake in. So once you have something that you're happy with, which I'm going to spend a couple more minutes tweaking, because I want it to be a slightly sharper. I'll probably add a crease there as well. So maybe that's the one. Goes from underneath, loops back up, comes back around, and then we can maybe just go forwards from here. Yeah, maybe that's something. Do that. I'm going to move this edge out. Let me check why. So I'm going to align these a bit better. It's not as bulging. And then maybe add a crease to this guy as well, so you can have a bit more definition. And I will probably just connect these and make a real sharp edge here. Okay. And then what I'm going to do is I'm also going to add probably the bulb at this point and maybe at one of the other ones. Probably not all of them, but just to keep some, probably on 3 out of the 4 or something like that. So extend out, scale, extend out. There's a little bulb on there. You can do Alt Shift, and then if you press on one of the edges, you can get a loop that goes around. And then I'm going to scale, for example, on the X-axis by pressing X and S. And then I might do that on the end here as well. Let me scale this one up instead so I can have it. And double tap G and move that back. Can take this one and do circle, and that will make it sort of a perfect square. So there's only 4 sides to it. Okay, so what I'm going to do before I go anywhere else, I am now going to take this and our subdivision modifier, go back down to 1, where you have sort of still a very sharp a shape. And I'm going to apply this modifier, right? Which will have added 1 layer of subdivision. So we've got like twice as many polygons. And now basically if I remove the crease, you can see that it's kept a lot of the sharp angles without having to have the crease. So if I transfer this over to something else, it would stay. What I am going to do now actually is still just to remove some of the data that I added, right? So like it will still help to keep the crease a bit, or maybe I'll just shift it over. I'm just gonna add the modifier back by pressing 2. So it's sharper than it would have been before, but it's not quite there. But I'm gonna use this line to sort of make my mesh less uniform, to have sort of tighter areas and less tight areas, so that when I transfer it over, I can keep a bit of this sharpness without having to have any actual subdivisions, right? But some of them might not be necessary. So like here, for example, this line that loops back around, and that's a full curve. I don't really care about because it's all smooth there anyway. I might also remove it, for example, up here. This line that transitions all the way through can probably be removed, and really only keep the geometry where I need it. So I'm probably going to remove like half of these as well, maybe just a couple of them. Maybe give myself a bit of a more interesting shape as well. And, you know, sometimes you can find something here and you can play around with it. So you can get proportional editing out again. And I think like here, if I extended this, a bit more interesting, maybe here as well. So I can sort of give a bit more shape to this, and maybe I'll sort of, ooh, not that quite that much. I was just gonna scale it a tiny bit. This one down here, I probably want to scale in, and I want to reduce, or maybe just shift over. We'll see. I've sort of selected a bit more than I wanted to there. Does that loop back around? Why are these things connected? And then this one can probably, this is a big one, a big line that goes all the way through the body, which is quite interesting. And I might choose to like, maybe I can scale this up or down to make something interesting. If I do delete it, it just sort of removes a bit of interest. There you go. But yeah, we're not gonna spend too much more time. I think we're about half an hour in. But I am still gonna delete some more items. Oh, that's a bit too much. Gotta delete it in the edge mode so that when going over, we just don't have too much like over definition, basically. Loves to select random edges when I'm not clicking anything. Some there. Scale that down a bit, maybe. Another thing you can try if you want to oh, so one question here from Björk. Any reason to design this specifically, do this in Blender rather than in Rhino, in sub D? Mainly because I guess, in the end, it is a personal preference. I find that Rhino's sub D tools are, especially when it comes to fast editing, are just not quite as intuitive, right? It requires more clicks, for example, to be able to select all these lines or to sort of delete them. And the operation sometimes when doing this sub D and Rhino, sub D is quite a recent addition to Rhino, and mesh editing is not its specialty in general. Rhino's from its start a more NURBS oriented software that has a bunch of add-ons for mesh and sub D, and Grasshopper is quite good at managing them as well. But I wouldn't say that it's really proficient at it in the same way a proper mesh editor like Maya or Blender or Houdini is. So that's kind of, I think, would be my explanation for it. The tools just aren't as fluid, in my opinion. But then again, that comes down to to a degree of personal experience, basically. Um, they're good for different things. Would be my take on it. But obviously, yes, you could do all of this in sub D. I think it would just take you longer, in my sort of personal experience. But a really, really sort of adept sub D user might scoff at that and find that preposterous. Okay, well, we have something that we can sort of go on and use. So, not spending too much longer on this, but if you want, if you've modeled something, you can use what you've modeled, or you can take the one of the models in here. So this is one that I did during my master's, where I applied a lot of the same techniques and then sort of reduced afterwards to have a lot less detail. Or there's a third geometry in here, which is applying similar techniques, but sort of a different degree. One thing that I forgot to show you actually before we head off into the world of Rhino would be beveling. So beveling is another way to get your geometry to be higher poly. I'm just going to copy this over for a second and then delete or hide. So if, for example, if I removed a lot of a couple more curves, I think we'd be back basically to pre-subdivision almost. Another way to get and to define edges is, for example, let's say you had creased this edge here, and you wanted to keep that really sharp when you went over to a different piece of software, like Rhino, or if you import it even from Blender to Maya or into Houdini or something like that. If you wanted to keep this crease or keep the definition there, one way to do it would basically be to bevel the edge, right? And by doing that in Blender, you press Control B, and that would allow you to basically turn one edge into two and put faces in between. The main thing to consider here is that when you bevel an edge, if you don't terminate the loop, you end up here with a face that has 5 sides, right? And traditionally speaking, that's what you would call an n-gon. And a lot of the software, a lot of the sort of patterning operations depend on you having nice and clean geometry, which means usually 4-sided geometry, or some of it 3-sided, but 4-sided is usually sort of the gold standard. And so here, for example, I've done, if I select, the entire edge here, I have a loop that goes back around. And in theory, if you bevel that, you could now get a series of faces where every face does have 4 sides because you've taken a loop and split it up into 2. And topologically, that still sort of clears the boundary, right? I have, let me check if I can see this, but I have a little add-on here. If I can show you, hopefully we'll see where is that settings? That'll be fine. No worries. Yeah, you should be able to see actually your see the amount of edges per surface, but I don't think it really matters. But this should be fine anyway. So now that you have this item, if you wanted to get it over to Rhino, first of all, I would say either apply or get rid of your subdivision surface. So you'll have something that looks like this, quite a blocky model. And then you go to export. A lot of these formats will import. I would either say OBJ or FBX are probably the ones that you want to use. For this purpose, it doesn't really matter which one you pick. But I'm just going to choose this, and I'm just going to type in, just call it number 1. Often here in Blender, you'll want to do limit to selected only. Otherwise, it will take basically the entire scene and export it, which is not what you want. And then you have a bunch of other options like geometries, what you want, if you want materials. For the moment, we're just going to keep those as they are and export wavefront OBJ. And then we're going to jump into Rhino. So let's get over there. Okay, let me sort of unclick this. So if hopefully you have some experience with Rhino. If you don't and you've never used it before, what I have a bunch of objects on the layers already, or on the first layer, which you can go over here, and hopefully if this will allow me to move it. Okay. You have all your layers here. Layers have names. On the default layer, I have a bunch of objects that I think in the file you have are hidden, but you can look at them if you want. What we're going to do is we are going to import our object. So file import. Let's get into Rhino and see if it allows me to open and get to where I need to go. It'll be in my little teaching folder. Webinar. here, I think. Okay, so we'll get our object in. So when you import the OBJ, you have a bunch of options. We are pretty much going to keep everything as it is. Map OBJ to Z in Rhino. I don't remember if the Z's are inverted or correct, but we'll see what happens. And so I'm in shaded mode, and it's going to import it. It's quite small. If you press the middle mouse button, normally it should refocus and allow you to have a look at your object. So here we have it, a little shape, something to work with. So the next step we're not going to do much in sort of Rhino proper, only a lot of selection stuff. We're mainly just going to go into Grasshopper. If you're unfamiliar with Grasshopper, it's in the standard panel, and then over here you have this little green icon that says Launch Grasshopper. For me, it's just going to open my tab with Grasshopper in it. So this is the file that's been sent to you. It goes from the stuff that's more clean and that we'll likely have time to do, and then to some sort of more experimental stuff that we'll see if we have time to finish up in the end. These are linked to all the components in the file before, but I'm going to be recreating these one by one, and hopefully just explaining stuff along the way. So let's see if we can zoom in. So if you zoom in enough in Grasshopper, you'll start to see the grid. In Grasshopper, so Grasshopper is the scripting editor for Rhino, if you're completely unfamiliar. The point is to be able to edit geometry and create parametric setups that you can sort of import and apply on, hopefully, new pieces of geometry that come in, and making scripts that are both reliable and sort of multi-purpose. Sometimes, depending on what you're doing, it's not quite as sometimes it's not quite your scripts aren't quite as versatile, and you just need it to work in the moment. Depending on how complicated it gets, you sort of pick and choose. To explain, basically Grasshopper is built as a layer on top of Rhino. And so when you want to bring an item in from Rhino into Grasshopper, you have to reference it. And all the editing that happens in Grasshopper is unique to Grasshopper, and then you can bake it to get it back into Rhino, basically like, push it back into Rhino. So in the first tab of Grasshopper, let me actually put in, if I haven't already, bifocals. Put in bifocals is just an add-on that allows you guys to see the names of things when I drop them in. So the first tab you'll see in Grasshopper is this geometry tab, which is basically filled with what's called containers, right? And these are boxes that hold the things you reference in Rhino. So for example, here I've put down the mesh, and if I right click it, I have the option to set one mesh. And when I click that, my Grasshopper panel disappears, and I can click on the object in Rhino, and I will light up in green, and it says, contains a collection of polygon meshes, and it says reference mesh, 556 vertices, 220 faces. So now I've referenced this item into Grasshopper, and I can use it. By the way, the visibility tabs in Grasshopper are up here. Sometimes you might encounter a file that somebody else has built, and the visibility settings are different. And these are really up to people's preferences. I very much like to have it so that whatever item I click on lights up, and whatever when I'm not clicking on it, you don't see it. I know that some people like to not have that and just have every item that is sort of visible in Grasshopper show up. And now that I've clicked that, I think it's probably going to try to show me all of the things in my file. So it's going to take a little second to render out. You basically, it's up to preference. Yeah, you see that now everything went red because I think we're inside of Lord knows how many objects that I've layered on top of each other. Basically, what it comes down to is if you like to have everything visible at the same time, you have to be diligent to go over, and whenever you're sort of done viewing an item, you have to go over and turn off the visibility by clicking middle mouse button, and then the pie menu, you can see disable preview. So basically, if I went over and said, took everything here, which again is gonna, and we do disable preview, hopefully should help a bit. But basically, that's just like I usually like to have my previews on and use the whatever I select turns green. But it depends really on your preferences. So now that we've sort of gone through that, let's get into how you actually edit stuff. So when you brought this mesh in, for example, let's start by saying, okay, I want to get this mesh from this very blocky view to what I had in Blender. What you would do is you would try to find a component that does subdivision. In this case, the plugin, I think the best plugin is Weaverbird that has a Catmull-Clark subdivision. And Catmull-Clark subdivision, you can see it has the names, the level, the smooth and naked edges. So it has these options that you can plug into. And so you can take your container and plug into these different parts and get a different output. So for example, if I plug now this mesh from one to the other, and you can see that now in green, we can preview. If I hide the component in Rhino, you can now see one level subdivided, right? Our original mesh is here in green and then one level subdivided. And so if I wanted 2 levels, for example, or 3, if I press space, you can open the search bar. That might have been confusing when I did before. Yeah, if you press space, you can open the search bar, and here you can type in, the names of components, and they'll pop in, or you can go and search them here, up in the top. For a lot of people, the search bar becomes more and more sort of the way to do it, because going into different plugins and searching for things becomes a bit of a mess. If, for example, you open a file, or even if you're navigating this file and you see a component that you've never seen before and you want to know where it comes from, if you press Control Alt and then click on the item, it will point you to, you can see it makes the arrows, and it points you to exactly where that component is. So this, Catmull-Clark subdivision is in the subd area of the Weaverbird tab. So that allows you to view that stuff. And to pop down a number like this, you can, number sliders will allow you to go between levels. To pop down some of that, you can just open the space, press space, open your search bar. And if you start to type in a number, it gives you a number slider. And this is sort of a smart number slider where it has a context built in. So if I type in 1, it will usually give me a number slider between 0 and 1. If I didn't type in a number between, so if I type in 1, it will give me a number between 0. This pen's a bit slow. 0 and 1. If I type in a number that's between 1, like above 1 and 10, it'll give me a slider that's 1 and 10. If you type in between 10 and 100, basically gives you a slider that's between 10 and 100. So just to show you, so if I type in 3, it'll give me a slider tops out at 10, bottoms out at 0. If I type in 15, gives me a slider that bottoms out at 0 and goes to 100. Usually loops around 0. If you want a very specific value, you can either double click the number slider and go in and give in your values here. Or you can, type in, for example, -10 ... 10, and that will give you a slider that goes from -10 to 10. Okay. If there are any questions regarding that, please type them in chat or else, or in the QA. So basically, yeah. If I type in 3 and give this, then you can see we have a higher density mesh. So if we want to put patterns on it, we're going to want a pretty high density mesh. So we can leave this at 3, I think. And what we're going to try to do now is we want to select parts of this mesh to put a pattern on, right? And so the way I'm going to show you is first to select sort of one of the more basic ways to select in Grasshopper is to select by distance. To do that, what I'm going to do is I'm going to put down a point. Just put down a point here. So I've put down a point in Rhino, which means I'm going to have to reference it in Grasshopper. Getting that, grabbing it over. Let's say we have our point here, right? What I want to do now is I want to take this point and calculate the distance between every face here and this point. And then I can decide whether I want, at what distance do I no longer want to put my pattern. So let's do that. So what I'm going to do is I'm going to go and grab the closest point component, which, as the name sounds implies, gives you the closest point. You have this component, and then you have one that's very similar, which is closest points with an S. And these operate in very, very similar ways, except for closest point gives you the singular closest point, and the closest points can give you a number of them, and you can give it the amount of points that you want. We'll see how we can use these just in a second. So what I need to do is, I have my point. I am going to get my point from Rhino. I'm going to reference it. So now I've referenced my point. Because I already had it selected in Rhino, it kind of auto-referenced it. And now I basically need a cloud of points. I need something that represents every single one of these faces so I can distinguish them. So what I'm going to do is I'm going to do use the component explode or mesh explode. And so I can take a mesh and, as the name implies, explode it into every single face on its own, right? I take every single face, and I'm going to use the area component, mainly because the area gives you the area and also calculates the centroid for you. So you can kind of use this component and get every basically center of every face, right? Hopefully that's visible. Every face has just one dot that represents its center. And so now I can calculate the distance from this point to the center of every face, right? So as you can sort of read the labels. And so we're going to put the point in the point and then the centroids in the cloud. Now, this doesn't give you I suppose it gives you the expected result, which is it gives you the closest point. It gives you the singular closest point to this reference point, which is, the point, I guess it's on this mesh face. But that's not really what we want. We would want every point. So you have two options here, really. You can either use the closest points component and take, for example, the amount of centroids here. Let's say we get what's the component list length. So we can get the list length. So we basically want this value that says up top here. It says 12,800 locally defined values. And list length will just compile that and say the value is 12,800. And we could get, the 12,800 closest points, which would give you every point in the series, right? In sort of your list. And that gives you the distance of every point. Another sort of, I guess, more clever way to do it is you can just swap around the logic of the closest point component. So if you say instead, my cloud of points is the singular point and my points are the centroid, you now have the opposite situation where, well, the sort of annoying part is that it tells you that the closest point is the first one, but it gives you every distance. And that's kind of what we need. In this case, we just want the distance so we can calculate, and so we can pick how far things should be, like allowably. So we have this distance, all right? We have this distance and we want to do something with it, right? We want to be able to discriminate. We want to be able to choose which points are too far away, which faces are too far away, which ones are close enough to be part of our selection. So what we're going to do then is we are going to basically just use a comparator, right? Compared to this case, there's a bunch of Boolean operations or a Boolean sort of operators. Here you have all of them, right? So you have addition, multiplication, and then you want your equality, larger than, small than, similarity, and you have gate and, gate nor, gate or, gate XOR, all these stuff. And so we can take all of our distances. Oh, by the way, I forgot probably to say, these guys are panels. You can get those by either finding them in the stack, or you can do Shift 2 to get the apostrophes that puts on a panel. Or I usually do just 2 times slashes, and that will also give you a panel. And they plugging those into your components allows you to see what the output is. Sometimes that's very useful for debugging, for understanding what's actually happening. So you have your distances, right? Every point has its distance from the other point, and this distance will be sort of larger or smaller. And we can see if we put down a bounds component, we could see what the sort of what the distance is. So 1.55 to 15.53. And if we put down a bar graph component, we could actually see how this distribution is laid out. So there's just a few points that are 1.54, very close. And then there's quite a lot of points that are about, 20, 30% that are somewhere around, I guess, 3, 4 in distance. And then it sort of tapers out, which kind of makes sense, right? There's a couple of items that are really close. There's a lot of items that are somewhat close, and then there's a couple items that are really far away. So we know right around where we need to cut off, probably around 2-ish is probably going to be our value. And so what we're going to do is we're going to take this distance as our first number, and we're going to compare it to a second number. I'm going to put in 2.55. I don't think I'll be needing the sort of upper end of the scale, so it's fine if my graph ends at about 10. And then this basically is compare the two and giving us a true or false. Is this distance smaller than 2.55? Yes or no? Then we can use the dispatch component, which is a family of a bunch of list operators that allow you to basically split up lists, right? Grasshopper is basically just a fancy list management software. Can you repeat? Sorry, Jawad asked if can you repeat the point thing? Can you be just a bit more specific, Jawad? About which point? About the closest point? Okay. Do you mean the difference between the closest point versions or the distance? Just making sure. Wow. I'll go back and sort of explain the full logic of how we got here, a little recap to make sure. So we basically got in our mesh, right? We subdivided it to make sure we have more information and more places we can put patterns on. We separated our mesh into a bunch of different items. So we exploded it. So we have every single face with access to the information of every single face. We selected the centroid of every face. So we're looking at the center, and we want to check, is the distance from this point that we sort of made in Rhino, how far is it from every single face? You could obviously select, just the edge of a face or some other feature of this face. Selecting the center just means you have a relatively good idea of where the face is and how far it is. You could have selected, vertex 1 of every face, or try to select, sort of a corner of it or something like that, or split it up and select something else. And then you get to all these closest point operators. So here, the closest point operators take a point and a cloud of points, right? So these are sort of like, a cloud of points. And we have our singular point. And so the way these guys operate, you put in your point, you put in your cloud, and it will give you, as the name implies, the closest point, the singular closest point to that defined point in Rhino, right? And there's a version called closest points where, you get the multiplier. And so you can tell it how many points you want it to seek through and give you the distance from. This one obviously has 3 inputs, so it needs a slightly more information. You need to give it the amount of points that you're trying to look through and essentially the amount of outputs that you want. One way to get away with having just the simpler version of the component is to swap the logic around, so that your cloud and your singular point are swapped around. So you have thousands of points that you want to find the closest match to, but the closest match is only 1 point. This gives you the output, basically the same output as the more sort of complex component. If we look at the outputs between these two, so you have 3.25, 3.4, 3.48, or 28. You have the exact same output, or it should be. I guess they have the list is probably ordered differently. It's probably ordered here also, probably sorted actually, in terms of closest to furthest away. Whereas this one is unordered, right? Just the unordered list of distances, which is a bit more useful in terms of keeping your list structure, because you want the distance here, right? You want it to coincide with which point you're looking at, and then with which mesh you're calculating from. Hopefully that makes things a bit clearer. The bar graph here and sort of the bounds are just helping you to estimate what that distance, what the result is. So in the bar graph here, you can see it goes from 1.54 to 15. So that's kind of the scope of your distances, right? They're between 1.5, I guess here it's millimeters or centimeters, or up to 15 centimeters away, or meters, depending on how you set up your Rhino scale. And so now what we've done basically is we were asking, is this distance between the 2 points smaller than 2.55, or is it larger than that, right? And it's giving us a true or false binary. It's smaller or it's larger, yes or no. We can take that information and put into a dispatch component, which allows you to separate items. And so what we want to separate actually is these mesh faces, right? If we take that and then if we plug that in, it will look like nothing had happened. It's because it's showing us list A and list B at the same time. If we type in mesh here, we can see basically now that it's given us that section of the mesh, right? If we compare this now to back here, right? We've selected out this part. So we now have access to this area of the mesh. Or if we select the other one, we have access to that area of the mesh, right? Interesting. And so what we can do here now is apply a pattern only in one area of the mesh, right? Or if we move this point around, we can change which area of the mesh we're actually affecting. We can move this over here and say, okay, well, the distance has changed. You see the bar graph update as well. And I can get just that area. And so let's do that. So now that you have these parts selected, let's say we wanted to add a pattern to this. The simplest way is using sort of pre-built patterns. And a lot of the good ones exist in Mesh Plus, which is an add-on that we'll be using. And so you have, effects, you have loops, you have a bunch of volume ones or subdivisions. But let's start off with, for example, like the anti-snub here. It's a huge component. It's actually coded in Visual Basic and sort of open source, so you can actually dig in here and look at the code if you're inclined like that and want to sort of modify things yourself, but you don't really have to. These unfortunately don't have like a longer name. They're just kind of, short like this. Usually, when you put in components, you can see they have a long name, or if you want, depending on your things, you can change. So this here in display, there's draw full name, so you can remove that if you want the really, really short version. But for this, draw full name is probably good. And also, you might have seen in some tutorials or online, some people don't have the icon. They prefer to have this sort of text so they can see and read what's written on it. I'm much more an icon person. I feel like it's visually much easier to remember what these do instead of having to read sideways all the time. So now we have this little part. We can basically say, okay, well, if we look up here and hover over, we can see this takes in a mesh or curve, and that's the geometry. And then it has a bunch of options. So index. So basically, I think you could feed this the index as well, and it would just do it on certain things. You wouldn't have to use dispatch. T0. So it's like these are basically, I think, thicknesses for this specific thing. And then distance, close, and then color. So we're just going to use the geometry for now. And you can see basically it's replaced every single one of these faces with a different face that has more sort of texture to it. And now we could basically just take, we have this textured one and we have this untextured one. And we could just mesh join these together. So take this and then say, plug the out from that and this guy. And then hopefully if we check, it's made one mesh. And so if we did custom preview, so we can see it a bit better, we can do this, plug the geometry into here, and then I'll get a swatch, which is just the color. And now if I jump over instead and go into rendered view, ooh, I think we're inside of other stuff. Let me. Who is it that's activated as a U? I'll have something else visible annoyingly. Yeah, there you go. I think. Are we at it? The custom previews act, unfortunately, sort of globally. So if you have one that's turned on somewhere, it decides to make itself known, basically. I didn't think I had, but apparently I do. Apologies for this. Let's try and debug. I'm just gonna deactivate all of these live. There we go. Let's take all of these off. Off you go. There we go. Okay. So you'll see it's also, right now it's black. That's probably because it is either the normals are flipped or there's some other issue. But we'll try to maybe start by doing a unify mesh. That sometimes works. And if not, then we'll use, there you go, unify mesh. So yeah, so now you see we've applied a pattern, a surface texture to one spot. Now it's pretty extreme in its distance. So maybe we'll sort of take here to the distance and put, well, slider seems like that's one in distance. Maybe we'll go down a bit, plug that to distance. So here you have a pattern applied to only one spot. And you might think, okay, like, we have this pattern. It doesn't really fade in or out very nicely. It's just one spot and kind of just like a, goes in directly from nowhere. So what we're going to do is sort of learn how do we make it so that the distance calculation that we've already done affects the distance, right, of each of these, of how much they're pressed out. So we can get a nice smooth gradient from in to out. And basically, I mean, you know, we have the information right here, right? We have the distance. So let's try and find a way to convert that to this, right? So we know that like at its peak, let's say, maybe we'll move it a bit further. We know that at its peak, we want it to be about 0.4 in height. And then we want it when it's fully, you know, as far away as it can be, maybe we want it to be just smooth, so like 0. So basically what we're going to do is we're going to take our distances and we're going to get a remap numbers component. And we're going to remap that number that currently is somewhere from 1 to 2.55 to instead be 0 to 3.6 or 0 to 0.4. So with remap, we have our options. So value to remap, source, and target, right? What we want to remap then is basically the distances that caused this. So we need to dispatch as well these distances this time. So you want to get these distances. So in list A, we have the distances that we need, and in list B, we have the 12,000 other ones that we don't. And if we check, we're going to know that the bounds here should top out at like 2.5. Yeah, so the bounds top out at 2.549. Perfect. So we have our values, right? Values here. We have our source, which is going to be right now. It's the default one says 0 to 1, but with the bounds component, we know that our source is from 2.1 to 2.59. Most effects components in the mesh plus have the error message. Any idea why? Error BCU bound is undeclared. Maybe unacceptable to protection level. It might depend on this might be like a version error. Maybe it's like are they like that from the ones when you grab them from the library? Because maybe it's like a non-updated version. Maybe if you're in Rhino 8, you might need like an updated one. Or maybe you have when you installed it, did you I don't know if it would show up or not if we install it if you don't unblock the files. But I don't know how familiar you are with installing plugins into Grasshopper. If you that is not the case, right? Yeah, I'm not entirely sure. That seems to okay. Yeah, let us know. Let us know how it goes. Give a shot updating it. It's not like, you know, if you want to just follow along for now, we can. There's other sort of thing. We'll be doing this like manually afterwards. So if Mesh Plus never works for you, then you can always have at it the manual way. Okay. So we have our source, which is this, and then we know that our target's going to be somewhere here, right? So I'm going to copy this over, and I'm going to do and use the component construct domain. So a domain is basically, you know, 0 to 1 or 1 to 0. And I'm going to put this, our domain starts at 0 and it ends at 0.36. Get that here. And so now we have all our values, right? And now we should just be able to say, okay, I'm going to take my values and I'm going to plug them into the distance, right? What you end up seeing is that it doesn't really work. Mesh Plus, for some reason, the way this plugin was coded, if these are usually Grasshopper does what's called list matching. And so if there's 162 values in one and 162 in the other, it will say, okay, each of these belong to this one. If one list is shorter than the other, they'll usually try to like loop the list around, right? So when it gets to the last one, like if it gets to like 150 and the other list doesn't have it, it will just loop back to number one and then keep going. Mesh Plus doesn't really respect that in this case. So what we'll do is kind of just like force it to understand the categories, right? And so I'm just going to unplug this for a second, and we're going to do, first time, I guess we're going to do what's called grafting. So what is grafting? When you try to match lists, right, between two things. So let's say here we have a whole bunch of items that goes up to 161. This goes up to 161. If you want to be really explicit that these are different buckets, right? You're putting things in different folders. If you use the graphed tree component, what will happen is that it will basically put all of these in its own bucket, right? So instead of before where you see that you go, they're all in the bucket 000. We can actually go here and just simplify. So let's say, I think hopefully I won't do it. Okay. Yeah, so these are all in the bucket 000. And now when I've grafted it, the first one is, in another bucket, 0, and then 1, 2, 3, and they're all in their individual buckets that we've sort of designed for them. And so if I do that for both of them, then the buckets will like match 1-to-1, right? And it knows, okay, these are different buckets, and I can put those in together, right? So if I, for example, took this and then said, I'm going to graft here as well, then now we have 0, 0, 0, 0, 0, 0, 0. And if I tried, for example, to merge these two, which you can basically join two lists together, you would see that it's managed to put them all in the same bucket, right? So the first mesh has its distance, the second mesh has its distance, and it's basically iteratively put all these in the correct bucket. Now, you don't necessarily need to use this graphed tree component. Every input in Grasshopper, or almost every input, I think, has the possibility to right-click on it, and you can rename it, but most importantly, you have flatten and graft. Flattening is the opposite, where you go, oh, nice, okay, upgrading Mesh Plus saved. That's good. So you either have the option to graft or to flatten. Flatten is the opposite, where you put everything in the same bucket, right? So what I'm going to do here is I'm going to graft. So I'm going to say, okay, every single one of these is its own bucket. And if I graft the distances as well, then hopefully when I plug this in, it will understand that these are all their own distances. We can see here that basically it's done the opposite of what we wanted. The reason for that, obviously, is that when we look at the source, the smaller the number, the closer is to the point. And what we want is actually the opposite. We want the larger the number to be to the point. So actually, when we're doing this here, we are going to set the domain start to 0.36. And then I can put in, just copy the slider over. If you hold Alt and drag, that will do that. And then drag that down. So now we have a pattern that fades in and out, right? And I might even, now that we have that, maybe I want the pattern to sort of be extended because we can fade it in and out. So now you have this pattern and it slowly fades out. And if you want to control how that happens a bit more, you can put in a graph mapper, which will allow you to control sort of the fall off a bit more cleanly. I don't remember if graph mapper does it. Alt 1 to 0, but you can put in, and if you right click graph types, you can go to like Bezier or Bezier 2. We're just going to go to Bezier. I'm just going to check the outputs here. I think it puts them all. Yeah, it should all be fine. So now I can just basically like change this with curves. And with this curve, I can decide basically if I want it to extend out to the edges a bit more or less. So I can make it really, really smooth transition into the center and then, really pop out at the center. So you put a pattern that basically transitions from smooth to sharp, from, almost non-existent to being really in the picture. So that's the very sort of the very basics of this implementation. Starting to think about how you can put a pattern on and put a gradient on it to make it slightly more appealing or interesting. Just have a drink. Okay. The next thing we're going to do then is explore just some of the other bits of how you could calculate this distance, right? How can you select these curves out? So what I'm going to do is I'm going to select these bits. I still want my mesh and all that. I'm going to hold Alt. Ooh, sorry, start dragging and then hold Alt. So you can move it over. And for now, I'm going to just hide these guys. By the way, before I head off to the next section, are there any questions? Anything that's confusing? Anything you want me to go back over? Anything that's bothering you? If not, I will keep going. I'll try to keep an eye on the chat and on the Q&A while I keep going so we can have a look back as well. Okay, so now that we have this mesh, let's look at controlling in a different way, right? So maybe, for example, I'm going to just for a second show my mesh. Ooh, not did I show everything? Let me give it a second. Ooh, interesting. To fix. Okay. Side view. Okay. Okay. So I'm going to do this and go back to the shaded view. So, okay, let's for example say, okay, I want to control this fading with a curve instead, right? I'm gonna put some dots down, maybe disable the grid snap. Don't want that right now. Okay, let's get a curve and say I want, for example, curve that does this. And then I'm going to go in and edit this curve by clicking Control-Shift-click the curve. You can see all the dots and everything. You can also make those appear by pressing, I believe, F8 or F10. Show you the points. There's also items in here. Here you can do show object control points. If Rhino is not your main software. Okay, so let's say we have this curve, right? And we want this curve to basically tell us, okay, I want pattern here and not pattern here. Similarly to the previous example, really, we can just do curve. I mean, like the way you might do it instead of just typing in if you didn't know is you would come here, maybe, you have, for example, that the closest point component exists, but you're not sure, is there a component for curves? Control Alt click gets you into, sometimes Blender's annoying. Ooh, let me just hide that for a second and then we can Go back to Rhino. You can go here in the points and say, okay, well, is there anything here? Pole point, closest point, on that. Doesn't seem to be an option here for doing anything with curves. Go up to the next one. Next tab is the curve tab. And here, analysis, what do we have? Analysis, control curves, blah, 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 blah. Point and curves, maybe in the utilities. This is kind of the job you would do. Either that or you're just using Google or ChatGPT nowadays, I suppose, to find your components. But basically, I don't know where it is, but there is a component. The other option was, oh, here we go, pull curve. I'm sure there'll be curve closest point somewhere. But if you don't find it that way, which it doesn't seem like I do today, you just do curve closest point. Maybe it was there. Maybe where were you? You weren't. I was right there in analysis. Analysis all along. Right down here, curve closest point, right? So you can instead calculate with a curve. So let's get that. Let's put in curve container. So we need to reference the curve from Rhino. Set one curve, set it right here. I want this curve. And here we're going to plug in the curve to the curve component and all the centroids to the point. And you see that's taken all the points and put them on the curve. But more importantly, it's given us the distance. How far away is every point from this curve? So what we're going to do is we are going to, very similar to before, you could actually basically copy what you had before, and might actually do that just to save out some time so we can get to keep going on more interesting things. But just copy this over. Get spaghettis everywhere. So basically, same as before, we have our distance, right? Plug that into the distance calculation. We got the thing we're going to dispatch, which is our mesh. Take those faces, right? Plug that into the list. The other one they're dispatching from before was numbers. And then I think the bar graph we can kind of do away with. So let's get that. We can activate these guys, and hopefully, if everything goes right, and we haven't broken anything, it should all work. I am going to just tilt over and see that, yeah, it seems like it has applied. So maybe we'll go back into the rendered mode by this guy and see what we have. So we see that it's applied it all the way, and it fades out depending on how far away it is from the curve. I might just reduce this number down because we're sort of kind of overdoing it with the pattern almost. And so you can get some nice fade outs where basically the curve is a lot closer here. So you get a lot of pattern, and then it fades out, and then it fades back in towards the end, right? And the things you can play around with obviously are within Mesh Plus, you have a lot of different options that will give you a lot of different looks. And depending, how you edit every other piece, you can kind of get whatever you want. So let's take this and try that as well. Might take a second. Oh, that's not. I plugged the second mesh into the distance. That won't work. This, hopefully. There you go. Let's see if that works. And then instead of the mesh join here, we could put in a merge so we can have a bit more option before it. I'm going to take bulk of that, look at this, and then swap that over into here, the mesh. Yeah, so here we see we have this pattern that goes along, goes to the edge. Pretty cool. Okay, so that's basically the first section of that covered. One thing to note for cleanliness in Grasshopper, and we're working with Grasshopper for those of you who are maybe less initiated. You can group components, right? So if I select all of this and I say I press the middle mouse button, then I have the option to group. I think it's also exists if you like, yeah, if you do this. Actually, no, maybe not. Yeah, just middle mouse button and press group, and then you have these as a group. And if you move them, they all move together. Um, how people like to group is sort of there's a lot of different opinions and influences. Some people like to group in color depending on whether it's inputs or outputs, and they like to stack all of their inputs on one end so they can modify them all at the same time. A lot of people do that if they have, they're sending these things to clients that are supposed to edit, sort of make design decisions themselves. Then you might want to say, you might want to move every single slider you have to the start over here, um, and be able to sort of group them together, right? So that you could edit all of your options and then you can name them all so that you know what they're doing. Um, I I am rarely sending these off to too many people, so I don't really bother with that. Um, I usually prefer to group by basically by sort of task, right? So the first thing we're doing is getting in a mesh and getting it to sort of the level of readiness. Really, this centroid could be in the next group as well. But then we're doing selection and uh, sort of dispatching. So we're giving ourselves a different section here. And then I'm going to move these guys over here. And then here we have sort of remapping, which is its own thing, in my mind at least. And then these guys are all sort of meshing options, right? These guys are just going to leave as they are. And then we have meshing and outputting over here. And how you color these is entirely up to you, or if you color them at all. But it can help. The other thing also to note is that if you type in, for example, if you type in scribble, you can put pieces of text on the board. And for example, say what you're doing in a component so you know for later. If you're doing, dispatching. And you can add this guy to add to group, and then that way if you move the whole stack, you know that this guy's part of it. Just a little quick little note on keeping things clean and tidy. It often ends up in sort of being noodle soup anyway. Okay. We will move on to the next little section, if I remember what I want to do. Actually, yeah, sure. Let's move on to the next little section. We're going to basically just copy over actually the dispatching section, and we're going to leave out the remapping for now. But what I want to get here is our two different meshes, and we're just going to have a look into, for example, if I had this mesh, how would I go about, let's go back into the shaded view. How would I go about making one of these patterns on my own, right? Mesh plus is all well and good, but I want to do something custom. I want to do my own thing. I don't want to just use these sort of pre-baked components. I have a really cool idea of what I want to do. What you need to basically build up is a way to edit a mesh on a single face level, and then manage your lists such that it works at a larger scale. So what I'm going to do is I'm going to put in a single face here. I believe that allows me to do that. Yep. Now we're just going to do, let's do this instead. Because putting in single face is going to be annoying, I'm just going to put in a rectangle. I'm going to do planar surface so I can get a surface out of it, and then I'm going to convert this to a mesh, just because sometimes putting down a single mesh can be I don't know, they're annoying for some reason to put down. So I'm just going to grab this. Maybe I can do, will allow me to just convert this to a mesh right here. To mesh. No, I'm going to do a bit of a convoluted way to get this mesh that I want to be a perfect square. You don't actually have to have it as a perfect square. I just enjoy that. Simple mesh. Get ourselves a nice and square mesh. Actually, what am I doing? I could just do, and I just do mesh plane. I could just do that. I think. Yes, that's what I want to do. Sometimes when talking for too long, you end up going down spirals. Okay. Please check the flattened graph usage in the section we did. It seems to not getting the fall off happening. Okay. Yeah, I can go that. So the important thing with the flattened and graphed is that you want these lists to match, right? So when you get the mesh here, let's put on a graph so we can just see what you're supposed to get. If you graph this, you get a full list of everything in its own bucket. One way to view it as well to make sure that it's correct, you can use a parameter viewer, so a param viewer. If you look at it and double click, it will give you sort of a view of the tree. So you can see you have one branch, and once you've grafted it, you have a lot of branches, to say the least. You want to make sure that the output here, when you graft it, looks the same. So I'm just going to go here, place that, and then basically if I graft it, check that it looks the same. If that's an issue, right? Basically the thing doesn't change. We're all good. And what you want to do as well is check here. So if you hover over it and you can check, and it says 1,503 values and entered it from one source, right? And you have sort of your structure, you see 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 2. And on your distance, you want to have the same structure. So you can see that it says 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 2 with the same amount. So 1,503. Do you have both of those things working? In wait of your response, I'll also yeah, no worries. The other thing to look at for you to have the fall off is this remap numbers section, right? So you want to have the dispatch going through both the meshes so that you're getting your two pieces of mesh, your one piece and second piece, but also your numbers, your distances, right? So you get your distances for the distances that match. So this is for this piece, and this is for the second piece. And we're really only going to use the A list. And then you're going to remap these values, right? So you have your value, your source, your target, and you have your distances that you're remapping them to. Okay, no worries. Glad that you got it working. Cool. So back to the next option. So similar to before, we have our dispatches going. So we got our numbers and our mesh. But really what we're going to do is now just work on a single piece of mesh, right? One little square. So let's set, if you press Control and drag, you can sort of unhook a wire. So now it's empty. I'm going to set this one mesh. So now I have one selected mesh. What I'm going to do with this guy is I am going to get the naked edge, which I think is mesh naked edge, maybe. Yeah, mesh naked edges, which is a Pufferfish component. And that'll give me just the boundary, right? And what I'm going to do is I'm going to then scale this in. So I'm going to go, let's say I take scale. And I want to scale it about the center. So I'm going to go, again, get the area. Take this mesh, right? Scale it about the centroid. And I'm going to say, okay, let's scale this guy. Scale the naked boundary down. So now we have a square that's smaller. And basically what I'm going to try to do is construct a mesh, right? That's going to make a little pattern on one single mesh. And then I'm going to apply that to the logic of the entire structure. I'm going to put in a factor here. Let's say we scaled it. I'm going to put in like 2.00, or I guess it's always going to be smaller. So it's 1.0.55. So like maybe I want, I want some of this, and then maybe I'm going to say I want to move the next one down, right? I'm going to take this guy. I'm going to maybe create like kind of like a window, like a windowsill. So it goes in and out, right? So I'm going to move it down in the Z direction, right? Because that's what we're doing at the moment. Move it down like 1.00. And there's going to be a lot of things here that we're doing now, and we're going to edit them a bit later. So I'm going to swap this to being negative value. I like to do it with a component instead of sort of typing in a negative slider. It's a bit nicer to do. So now basically what we have was one square in, one square down. So yeah, one square in, one square down. We're going to go in and then up, let's say, right? So we'll copy this scale. We probably here want to take our new found geometry here. Let's say we're scaling. And we want to scale the geometry we just had. So now we've gone in and out, in and out. And then we'll move it back up. Take this geometry and move it back up. So instead of negative, we'll go positive. Right. So now we have basically like four operations, right? We're going to create this little sill, like go in, go down, go over, go up. And that's what the square, the mesh we want to create. So how would we sort of link these, right? So in each of these, we have a square, we have a polyline curve. I've found the best way to do it is with ruled surfaces. You could try to loft. The lofts are sometimes just a bit finicky to deal with correctly, right? And so what I'm going to try to do is I might go back here, right? And explode this curve. Will that be okay for the next part? We might just explode it every section, right? So we're going to take this one and then explode as well here. So now basically with exploding the curve, we have lines at every section. And because these are all the same line, we know that they're all matched one-to-one, right? So first I have this line here, and then I'm going to have this line here. And if I try to join them, they're gonna be structured correctly because we're building off of the same basis, right? So here, and then let's explode here at the end as well. And let's explode here. And now we have the slightly tedious job of organizing all of this. So we're just going to grab all these guys, organize them properly so we know what we're doing. 1, 2, 3, 1, 2, 3, and then we're going to move them all slightly more forward again and grab them over here. And so now if I do, because my sort of lists are organized correctly, which I can show you here, basically it's 4 lines every single time, right? 4 lines, 4 lines, 4 lines. And so now if I say, let's graft every single one of these, graft, 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 and graft, what's happened is I'm put them all into individual buckets. And if I try to join these, I've now basically joined, this line to this line, this line to this line, this line to this line. So now I've basically made a nice little join. And then I can just keep going where this time instead I want, B and A to be this. So now I've gone the same thing, but down. And then same thing here. We're going to go from here to here instead. And then same thing here. We're going to go from here to here. So now we've gone, in, down, in, up. And maybe we'll just leave it open at the end, right? Okay, so now we have, this is basically our structure. Basically is our structure for how this mesh works, right? How our own component, our own sort of pattern works. If we try now, let's say, to replace this mesh with this one, we will probably have some problems, and then we can try and solve them and try to understand why they happen. It's probably going to give us something crazy, but we'll give it a second to calculate. And then we can sort of have a think about why it's gonna be real crazy. Okay. So what do we have? First of all, we have our mesh, and then the real problem is that we have the mesh naked edge. And what are we doing? So we're scaling, and it's not liking that. And why is that? It's because when we look at this mesh, we're scaling with each of them by their centroid. So hopefully we have our naked edges all good. That's fine. And then the centroid should be matching for every edge. But this one, as you can see, has a different structure where they're all individual buckets. So I have to flatten here so that these guys match up in their structure, and hopefully that solves it. It goes from 20 seconds to a couple milliseconds. So now you see we fixed it so that they're all scaled correctly, at least the first time around. Now let's look. Okay, so before in our example with our own mesh, when we moved in Z, right, when we moved down, that was the normal direction of the surface. We got it moving up and down. Now, actually, Z is no longer the correct option because we're just moving all of them down. So what we want to do instead is we want to get the face normal, right? We want to say, okay, each of these faces here that are exploded has a normal direction. If we do, let's do display, vector display. We can do center anchor. We can see that every single one of these faces has a sort of pointing out direction, right? They're pointing towards something, and we want to move in the opposite of that direction. We want to move down, but like into the mesh. So how do we do that? Well, before we had a Z unit, and really we just want to replace the Z unit with this direction. So we can use the amplitude component and take the normal. We'll make our amplitude this, but we're probably gonna want to keep the negative direction, right? So we're gonna remove the Z and instead plug in the amplitude to there, and then plug that into there. And we'll probably have to scale down this motion because I assume it will be a bit different. And it's also frozen because, as you can see, this wire here, when it's dashed, it means that it's grafted. So it means that you have multiple buckets that you're going with. And so you really want to try to keep the same level of wire, unless you know what you're doing. And just a specific reason for not sort of doing it. See if we can get out of this calculation. Okay, 20 seconds on that. Let's try and fix this guy. Oh, maybe we'll stop scrolling in. Okay, so what do we have at our issue? We have a lot of buckets, and we have only one amplitude, which is actually probably what we want. We want every one of these to be applied with the same amplitude for now, at least. We might want to scale it later. But really, the issue is here with the move component, where we have a lot of buckets and no buckets. So hopefully, if we flatten this, right, coming out of there, again, seems to have done wonders. And now they should all have moved inwards by an amount. Let's see if that makes sense. Does look like they've done that, but I'm probably going to scale, it seems like they're moving quite a bit inwards, and we're probably going to scale this down. Obviously, before we were working with a mesh that was quite a bit bigger. And it might be good, here I'm working with a very small mesh, and so my numbers end up being quite ridiculous. It might be good to scale the entire mesh up at some point. And I might do that now, just to scale it by 10, and then if we'll just leave it for now. Will we? No, let's scale. Okay, I'm just going to go back here, scale the entire thing. That will have an effect on, we're probably just going to scale it at this level instead, shall we? And it's going to show me this guy again. Hide, a bunch of stuff I have here. I'm going to take this guy and just scale in Rhino, scale it by 10. This is the base point, press that for 0, scale factor 10. There we go. Make my life a bit easier. Which means that these numbers here will be thrown on. I think the distances will instead be like 10 times higher, so it should be 20.2. And that should fix things. Yeah. Okay. Back in business. So now we'll have a bit of an easier time sort of moving these guys without being absolutely ridiculous in terms of our scale. So I can probably go up to, it would be 0.5 or something like that before it starts causing trouble. Ooh. Okay, so now it's moving down. And then the next one, we're moving in, right? Let's make sure that so all of these guys Geometry. Curve must be planar for area calculation. Okay, so it doesn't want area when it's not planar, doesn't want it. We can probably use the centroid component. Actually, we're going to use the polygon center. A lovely little component that does almost the same thing. And hopefully that one works when it's non-planar. Let's see. Not a complaint. Average polyline edges or area centroid of polyline shape. I think we're going to use the center for this guy. Plug that in. And so now we've been able, hopefully, to scale that guy down. Look at that, wonderful. And then we move it up. But here again, probably not moving in the Z. We're gonna want to use the same strategy as before. Take the amplitude component. We've already got the normals plugged in, and so we just want to change the amplitude to 0.3, moving back up the same way we did. And we'll see if we did anything wrong. Maybe we did. Probably something. So what do we have here? Buckets, no buckets. Probably just line this out. There we go. Okay, so now we have all of our curves, and let's see if that has worked out. First, second, third, fourth. Look at that. All right, so now we have our own little pattern. And so now what we can do is we can take these guys and we'll do, we really just join BREP because they are, after all, just BREPs at the moment, I believe. And so we're just gonna take these guys. We're gonna use a merge component in between just to make sure that we're doing it all correctly. I'm gonna flatten all these out. Now it doesn't really matter which category they're in. They're all just kind of the same. Let's see if it manages that. If it doesn't really want to join them as BREPs, we can always just convert them to meshes. And the mesh joining sort of procedures are often far less stringent than BREPs. NURBs are a bit more of a pain than meshes are oftentimes. Okay, probably best to leave those guys as meshes. Well, that unfreezes, we'll do that. While we're waiting on that, if there are any questions, feel free to chime in if there's any bits here that felt confusing. Oof, it's not that, is it? There you go, 1.3 minutes. So mistakes were made. Let's delete the component. Whenever it feels like it, hopefully it'll unfreeze. Oof. Okay. Come on. All right. You know what? I think we're about 2 hours in anyway. So why don't we take a little 10-minute break while my computer decides to unfreeze itself. And hopefully at the end of that we'll be back. If that works for everybody, we'll do 10 minutes. And so we'll be back at 1925. All right. See you all in 10 minutes.
Hey, Oscar, I see you moving around there. Just don't know if you know
Yeah,
you're
yeah, no,
muted.
we're on break.
Okay.
For about three
Just saw
minutes.
you moving around, so I didn't know if you knew you
Yeah,
were
yeah,
still
yeah.
moving.
I was just cleaning up my little cursor.
All
By the
good.
way, Mike, I was a question. Are they I'm guessing I know the person I know the participants have mic permissions, but there's not that many people, like they were like 13 people in here. It could be like more lively if they are allowed to sort of chime in, but I don't know if that's something you guys are sort of just don't do generally.
It's not possible on webinar
Okay.
Zoom unless they're panelists like you are.
Oh, okay.
Yeah.
Fair enough. Yeah. Like it might be a thing that'd be nice for well, I don't know if Zoom just doesn't allow it, but
Just not for the webinar one.
yeah.
Uh, if we did like a meeting, then
Mm.
it could do that. But then we lose a lot of other features.
Ah, okay. Annoying. Okay. Okay. I hope everybody's gently trickling back in. Um, we're gonna start on the next little bit. Okay. So where were we? We're at the final parts here of having all of our. I need to turn off this so we can actually preview some geometry. All of our mesh bit, all of our surface bits, and so we have a bunch of untrimmed surfaces. What we're gonna do is we're gonna put down a simple mesh component. And what this does is basically just convert from um, from a brep from like a surface to a mesh in the simplest way possible, which works really well if you have like planar surfaces, right? Or you know they're flat and you just want it to become a mesh. So hopefully that works and not too much of a hassle. So yeah, as you can see, it's made all of our panels into meshes. So we have a bunch of unjoined meshes right here, and then we're just gonna plop those in and join them. This is a bit of a slow process, so you got to kind of watch out, especially when you're doing this many of them. So I might actually, go back to our curve, our dispatch here, and just reduce the sort of allowable distance a bit. So we just have a bit of a fewer. Okay, so Bjorn is asking how to actually combine the transform mesh with mesh prospect with the original mesh from the very beginning. Right. Good question. The thing you only need to do is just put down a mesh join, right? And that should should basically merge the two back together. So back when you dispatched, right, and you separated the two, you have you should basically have your part and the gap. I think maybe I'm doing. Oh yeah, because this one maybe we should put down a larger value since I scaled everything up. Oop. So when you dispatched, right, you have one section and then the other, and then you can just kind of join them back. When you plug these next to each other, they should wrap back around and know that they can slot in. So same thing, same process now basically, right? So we have our new, custom made mesh, and we have our original mesh. We're just gonna go and grab that one. So we can go and grab this guy and just join these guys. Join them back up. 1, 2, bish bash bosh. Let's get a custom preview so we can see it as it's intended. And you can see here, again, sometimes we get a normal problem. So we're going to do unify mesh. Basically just shows black because the inside and the outside are just a bit wrong. So yeah, here you have like a bunch of windows basically that you've popped in. Another thing that can be useful here is to do pull out the Campbell Clark subdivision, because it can always give a slightly more interesting look to your panels. Here, it'll round them over a bit. And then obviously you can play also with the thing you've just built. So let's say, for example, I wanted the scaling to be more aggressive. Then you can scale it down further. And you could also, what we probably should do is make this variable on the distance. So we'll take our remap from before, right? Go and grab these guys. Copy these guys over. And I'm going to say, so my list of numbers are this one. Same here. And I'll plug this in. And I'm probably going to want, instead, I want the factors to be up to 0.58. And I often don't want it to go to 0, because it sort of gets a bit funky when you're, multiplying, dividing by 0, doing all these things. It doesn't really like to work like that. So yeah, now you can see that the pattern is fading depending on how far away it is from the curve. And so you can either edit your sort of edit your points on how much that does, or you can also obviously go in and edit the curve if you wanted to have that be more aggressive. But that's how you build like a custom pattern. And this is obviously like a relatively sort of short version. Any chance to get the Grasshopper file to play around with after this course? Yes, I can sort of upload this and send it on the end of the webinar, so you can have a look at the things we did in it as well. This whole file with all the other references is in the like not the ones we built during the webinar, but very similar ones that are sort of right over here to the left. What I was going to point to now was for example, this type of structure. Let's see if this guy wants to work today. It might not want to, actually. We'll see. This type of structure works as well on a slightly larger degree. Let's see if we can just turn the preview off for this one and go and have a look. So here's, for example, a different structure, right? Where we've done very much the same thing. It's a bit messy, but you know, it's here instead of moving moving the entire square. At one point I separated out so that I can take just a single curve and move the endpoints, move those up and move those over so you can get basically a skewed look, right? So you basically break the square and reconstitute it so you get these sort of dimples instead. And this is in the file and you can have a look at it. It just takes a bit more time to set up. And so I wanted to be able to cover some other things instead. But you can go and have a look at this after the webinar, and it might be hopefully a bit instructive. But the principle is in effect the same. You know, you end up at the end and you get some ruled surfaces and you convert it to a simple mesh, and then you unify it back and merge it with your existing mesh. So those are the first bits on that, and then let's see, what did I plan for next? Yeah, sure. Okay. One thing we can have a look at now is so in some of the promotional imagery from this webinar, you would have seen sort of a shape like this, and then a structure underneath, right? That would be more more solid. So let's take some time and just make that, and then we can have a play around with how we link those together. So quickly go back to Blender. I'm going to add a new cube. And I'm going to build sort of a underlying, very sort of mechanical structure, right? Or that's the idea, at least. I'm going to take this guy, let's say, and I really just want it to be very low polygon. But so I don't need to make something very, very fancy. But let's say, you know, I moved that forward there, and let's say I moved out some kind of 45-degree structure over here, right? And if I imagined I want it to go down here, and I'm going to say it links up. I'm going to this one back a bit so I can take it and protrude it down. This forward. Maybe actually I'll extrude it first. Oop. Yeah, there you go. Let's do that. I'm going to scale it back on Y to 0. I'm probably going to move this down a tiny bit. All over here. Gonna add a little section and maybe use that, let's say, as in pretend that supports this arm. I'm just trying to build something that's not too complex, that's quite low polygon, not going to take up a lot of memory space, but with some texturing, could probably do a nice job. So let me do one last bit over here, and then we're going to look at how we can add some sort of flair to it through projecting curves, right? So let's say we had some of that, right? A little sort of stick guy that's sitting underneath. I'm going to export it. I'm going to choose, we'll keep going with OBJ for now. Just going to name it 2. Select it only, export OBJ. Head back into Rhino. And again, you could have just built this in Rhino. I just frankly feel I have a bit more more control in a software designed purely for mesh editing. Import. Let's import the mesh, and we have to remember to scale it up 10 times because otherwise it's going to be too small. Select our guy. And then go and scale. 10, okay. What do we have here? Okay, it seems like I probably moved it at some point. Doesn't really matter. We'll just fix that. Move this down. And so I have this, my support structure. And what I'm going to do is I am going to now use some Parakeet components. So first of all, I'm going to import this mesh. Ooh, select a little tiny mesh instead. Fun times. Okay, here's our one mesh. And I want to get some curves along this thing that I think will add some flair. For one reason, I'm going to flip it 90 degrees. Probably actually do 180. I want this side to be top side. And I'm going to go into Parakeet. And I want to flow some curves along this. And so Parakeet has a nice component called flow path, generates discrete fluid motions on a mesh. So what I need to do is define some start points, step, flow direction, duration, and flow resolution. Take my mesh. I am going to get my start points. Mainly here, I'm going to select just this edge. While I'm at it, I'm going to go here. I'm going to say dupe edge so I can get this guy. Curve. Select that one curve. And I'm going to divide this curve. Get a couple of curves that sit on the edge here. And I'm going to use these points as my start points. And as you can see, it's basically started moving these curves down my body, right? And what I'm going to do is I am going to increase the step size. So distance between two consecutive points, I'm going to make this something like 5. Because I don't need that high of a resolution. I'm probably going to make it a bit higher. Maybe we'll start there. And then start points iterations. We'll probably just increase the iterations actually. So let's make it 50 and then decrease our step so it's not 9 units. This is a bit much. So somewhere along there. So now we have some curves coming along this path. And basically if we said like now we want, okay, I want a polyline to be defined by this, then you could do that. So you see it's already divided up into these chunks. If I put vertices, I would get polylines that go down it. These polylines, you know, it's right now it's just kind of straight, which is not super interesting. You have some deviating onto the side, but we want them to look a bit more like mechanical so we can sort of contrast with our more organic shape, right? If we're going to make that look, then what we're going to do is we're going to use the discrete polyline component from Pufferfish, I believe. Yep. And we're basically going to take these, and we're going to use a vector star, if I remember correctly. The vector star basically just defines a number of direction vectors, right? That it allows these guys to move in, these lines. And so our targets are these vectors. Our references are these original polylines, if I remember correctly. Or do you want references? Do you want the points? Reference vertices. So we can take the vertices from here. And hopefully now it should have made polylines where it only allows it to move in a certain direction. Now here it's still a bit too chaotic. It doesn't really allow it to move down. So what we want to do is both first change the plane. So we don't want the world XY. We're going to want the world ZX or one of those. We'll see. Let's do XZ plane and see how that treats us. XZ plane, a bit strange. I think it will be the Y plane, YZ plane. Let's see if I'm not mistaken. So it's still acting up a bit, and one of the reasons is because the dimensionality. So true for 2D, false for 3D. We're gonna want these guys to be, are they? It's already false in 3D. Subdivision type, circle cubic, steps, number of subdivision steps. And I think we want to add 1 or 2, if I remember correctly. If I'm not mistaken. Just a little bit weird. What did I do last time? Apologies. To remember. Vector star 1 target keeps length. Okay. Well, let's see if I. Yeah. Okay. So that's it. So you can see here now it's added. It has taken these polylines here where it's a bit smoother and made it to a bit more jagged. The addition here we have to make is our current mesh is just like a bit too smooth, right? We just don't have enough information to get interesting deviations between sort of these lines. So the method I've come up with to make these deviations is basically just to do a simple subdivision. So hopefully, if I remember correctly, what is the component for that? Yeah, Weber's has a constant quad split. There you go. Okay, it's a sharp subdivision. So, if we look into, I'm just going to put down a Weaver bird component so I can pop over to the tab. In the subdivision types, you have this Camel-Clark subdivision, which is the one you'll be most familiar with if you use both subd in Rhino, if you use subd or subdivision modifiers in Maya or in Blender, and then you have just constant quad subdivision, which you'll see in some software as well, which is just kind of a sharp version of it, right? And so what I'm going to do is I'm going to divide this at probably like a level 4 or 5. 5 is probably a bit extreme, but we'll see how it happens. We'll go to 3, get ourselves a bit more information. And then I am going to deconstruct the mesh. If I can type, that'll be easier. Deconstruct our mesh. And after having deconstructed our mesh, what we're going to do is take all these vertices and move them around a bit, right? This is the equivalent of kind of adding a noise modifier if you've done that in some other software. But here we can just kind of take the list and I think just jitter it, which is, will that jitter the, what did I do? Did I move in random? To remember what this is. Oh, actually, yes. Move amplitude. Yeah, okay, no, it's much better. Sorry about that. We're not going to jitter because jitter is for one of the different scripts later. We're actually going to do is we're going to take the normal direction and just move the vertices in the normal direction by a random amount. So random, we're going to take these vertices, right? And move them about. It's annoying when you build. I'm going to move these way far away so I can have space to build. Okay. So what we want to do is we want to move these, basically move these points along the normals, right? And here you're just moving them 1 point out. And I want to make sure that I'm moving them, some of them more, some of them less, right? So the best way to do that is to take the normal vector and basically randomize the amplitude. So we want the number of random numbers, right? We need a number, so this is the amount. Take the vertices, we want the list length, so the amount of vertices we have. Plug that into the number. So now we have 2,690 items. The range from 0 to 1, that seems fine. We can change that later. And then the seed, we could also add something for that later. But basically, vector motion. Now we've moved all of these points in and out very slightly. All right. And we could now just do construct mesh and rebuild our mesh as we had it before. We've not changed really in any of the orders of things. We just moved the vertices positions. The faces are still the same. And we'll have a slightly wobbly mesh. It's like having added a bit of noise, a bit of randomness to your mesh. If we take this now and sort of plug this into our flow path instead, now we'll have points that are moving a bit more randomly or scattered about a bit. So now you get something that looks a tiny bit more, sort of techy or circuity because they're sort of crossing and they're going and doing these things like a scaffold that's sitting on top of your structure. And we've added this on one side, and obviously you could, if you change the points, you can add it on multiple sides, and you can change basically how much these are moving by changing the amplitude. So maybe we just do a multiplication. You could either change obviously the range of the randomness, or you could just multiply all of them, and some of them obviously are larger, some of them are smaller, and so you'd get just more in general. Take this, multiply. So now it's more wobbly. We'll see what that gives us. Kind of a more chaotic pattern. So as you drag basically this slider up and down, you should see it go from sort of less chaotic, in a certain sense, to, if you drag it up, to more chaotic and going off on the other limbs of the structure a bit more, which I think can be quite interesting. So these at the moment are just curves. If you wanted to convert them to sort of meshes or tangible geometry, what you want to do is take these polylines. And what I would do first is probably extrude them with a simple extrude. So I'm going to take these, extrude in the X direction. So now we've created these sort of flat bits. And I'm going to say like that, but I'm going to put 2.00 just to have a bit of a thicker structure. And then from these guys, I am going to then offset mesh. We should thicken it. So these extrusion now are probably B reps. So I'm also going to do simple mesh to convert them into meshes that are just the same as the quads. So we can keep the geometry very, very plain and simple. and then offset, and then you'll have a thickened item, right? So now you have these cables that are running along your structure, basically. Instead of having them be these are more organic. I mean, you could also, if you see the structure and you're like, oh, okay, well maybe I can do something that feels more organic with these. Instead of going from a polyline, you could probably do interpolate. Let's see if I can not put spaces in my words. That will be helpful. There you go. If you did interpolate instead, you could take these flow paths and maybe make them into more solid curves, and you could probably increase the degree or reduce the amount of curves if you wanted to. If you'd reduce the iterations but increase the length of the steps, then you can get something that's far more sort of organic. So it looks almost like vines. Why do we select one edge to play from the first place? Can't we just play with the faces directly? The reason to select one edge instead of sort of the face directly, the reason here is that the flow path input wants start points, right? So what you could do, obviously, is if you wanted to select, you could, for example, do mesh and kind of like, if I do that and duplicate, let me duplicate. Don't really want to. If I do, let's extract. If I extract the surface at the top, right? We can do this. So one mesh will allow me to convert. No, I don't want a surface. Okay. Let's do surface. You could basically do this and say, okay, I want. Okay, so not gonna play along. Okay, so now my surface, I'm going to select the surface here. Okay, actually, whatever. We're going to duplicate the border and get a planar surface, something like that. Because it doesn't want to, obviously it's a mesh, so extract surface is not going to work. Probably just take this curve, can't I? Yeah, okay, let's do that. What I want to show is just that you could populate this this surface here with points, basically, if you wanted to. But kind of what you're going to end up with. Extrusion. Okay, is this a surface? Does it count? What we end up with is just like the vines that go all over the structure. And so selecting an edge just makes it more controlled. So you could do this and do populate geometry, for example, right? To get points all over the surface. And you could put these points into the start points. And then you would get things that flow all the way around your structure. The reason I selected an edge was merely kind of just to get stuff that wasn't as chaotic. The more points you have, the more sort of extreme it gets, if that makes sense, and sort of harder to visualize what you're doing. Does that make sense, Jawad? Cool. But yeah, so hopefully that's something that could be useful to you as well. So that was a very brief interlude. We're going to go back now to another way of doing mesh patterning. And then after that, we'll follow up with some more curve exercises as well. So going back to mesh patterning, we are now going to delve into mesh patterning with pufferfish. And to do that, we're going to do some steps in Rhino before we head back in. So if we have our geometry. We're gonna have to show everything in. Really, I should just clear all this stuff up, but we will survive. Okay. So just for a second, we're gonna just be in Rhino. So what we want to do is we are going to convert this to a NURB surface, and then we're going to pattern on the NURB surface using Pufferfish. So from this mesh, we're going to go to sub D first. This is a bit easier to work with. So got that. I'm going to take, I think it's selected only the, yeah, okay. Let's take this guy, move it a bit to the side. So we have our sub D mesh. And then I'm going to look at the, what was it called? Sub D face. Set color per face pack. So now I can look at, before I convert to NURBS, I can look at how Rhino is going to interpret this as NURBS, which we can also edit afterwards. But I think it's always pretty interesting to look at. And we can see that these big surfaces are going to become one big surface. You can have split it up to one big surface and loops around here. I think we have some really interesting opportunities to create patterns that flow along these surfaces rather than on the mesh structure. So if we do that and go, I'm going to undo the coloring and go to NURBS. We're going to keep the input object. So as you can see, if we now grab the NURBS object, polysurface, and move it over, hopefully it'll allow me to. You can see that it's basically packed these surfaces exactly like it told us it was going to. If I go back to set per face color by face pack, you can see basically there's one surface going here, there's one surface going here, there's one surface going here, and we are going to pick one of these and apply a pattern onto it. So I think I'm going to pick, let's pick this surface. I'll pick the surface and say, okay, how do we get a pattern that flows along this area here, right? Well, let's get started. So the thing we're going to need to do is, again, define a pattern, right? I'm going to probably, you can just build it, hopefully, in here. So let's go to our mesh tools, put in a mesh plane. I'm going to make my count 4 in both X and Y. And I'm going to make it square. What I'm going to do next is I am going to select this edge here, this loop here. Where my, okay, it's been selecting over there. This edge here, and let's say, for example, we scale both of these in. Scale both of these guys out. I'm gonna move both of these up just to create some kind of pattern. I might actually add one more. Where are my insert edge loop tools? Slide mesh vertices, I believe it's here. Insert edge loop. Sorry. Insert edge loop. I'm insert one on both sides. Doesn't have to be symmetric. I'm going to scale. Once I get this guy, I'm going to scale him down as well. So what I'm doing here is basically creating my pattern mesh. But this time what I'm trying to do is I want to make a mesh that I blend through Pufferfish. And so the rules are a tiny bit different. Well, let's say we have something like this, right? Relatively simple mesh. And I probably want, just for everything to be a bit nicer, I'm going to make sure that the corners have 0 elevation. I do want, sorry, undo that. When I'm scaling to 0 on these corners, I want to make sure that the gumball is located at the vertex, that is at the bottom, so that I'm scaling to 0, scaling it flat, and not scaling it up the other way. So I'm going to do that. Gumball here, and then scale that to 0. Okay, so now we have our base mesh. We're going to make a copy of it. Can copy it just in place. And the copy, I'm going to, again, relocate the gumball, put it right in here in the corner. And I'm going to scale it to be entirely flat. So now we have, in effect, is 2 meshes that are exactly identical, the same mesh, but laying on top of each other, right? And what I want to do with these is basically blend in between them. So I have my mesh. I'm actually going to maybe even go back here and copy some of the selection criteria. So we have, actually, sorry, what am I saying? We have our mesh. We actually have what we want is this this NURB surface. And so we're gonna go into Grasshopper, get our surface that we want to pattern onto, and we're going to create a twisted box surface. So now let me select this. Let's explode this for a second. We can extract surface as well. There we go. Surface, polysurface, set one surface. There we go. So now we've set this surface as the one we're going to be working on. And I want to go into Pufferfish, into the twisted box library. And we should have in here twisted box surface, which I might just search for because finding it, twisted box 2 surfaces, you just want to hear about twisted box surface. And what this will allow us to do is take the surface and then it's building, as you can see, maybe these squares on top of the surface, right? Which are boxes that we will then be able to fill with our mesh. It's a bunch of options. We have options for thickness, we have options for the parameter. So the parameter here is the amount of boxes per division, right? So the way that this component wants it is clearly that it wants between 0 and 1 the number of it wants a number of divisions. So we're gonna get the range component, which allows us to do just that. So you can see the range has a domain of 0 to 1 and a number of steps within that range. And so the output here is like 0, 0 0.1, 0 0.2, 0 0.3, 0 0.4. And what you get to do is basically plug that into V, and then we'll make several one for you. And then now if we, let's say, let's say we wanted not the same amount in different areas. You can get in here and edit your amount of, maybe we'll take this surface actually and just move it over, let's say 500. Hopefully that's not too far. That is too far. 100. There we go, so we can see a bit better. So we can see the surface, we've added on that part, and we can select basically how many divisions we want on top of it that we're going to fill later with our mesh. So you also have applicants parameter W if you want to stack multiple boxes on top of each other, which it's doing at the moment. And so what we actually want, we just want one layer of these boxes. So we're just going to put in 0, I believe, and hopefully that will give us just one layer of boxes. Or maybe it's 1 that I should put in, probably 1. So there you go. And I have 1 box, I believe, that is 2 units high. And so we can probably change this thickness, put in 1.0. I don't want it to be too high. There you go. So now we've set up basically the parameters of the boxes that we are going to be filling, right? And so now what we have to build is the boxes that contain our mesh. So over here we have our mesh. And we basically also just want to go and grab some twisted boxes right here. And twisted box mesh, right? If I remember correctly, let me just go check that I am not hallucinating. Morph twisted box is the one we want. My bad. So we're going to go and grab morph to twisted box instead. Just type it in. Just finding it. Morph twisted box. Morph geometries from reference boxes to target twisted boxes. What we are going to do is we want to import these meshes into Grasshopper. So like always, get some containers, get 2 of them, set 1 for our extruded mesh, set 1, grab it, for our flat mesh. So now we have our 2 meshes. And we are going to take the bounding box. So this is just the box encompassing the geometry. And we're going to take this for the bigger of the 2 geometries, right? And we're going to say, this is our geometry. This is our reference. And then the targets are going to be these twisted boxes. And we're going to do the same thing for the flat mesh. And the reference here is going to stay the big box, right? Because we want them to morph correctly. Like the flat one still exists within the bounds of the big box. And so what error is it? Target, since the targets here are going to be these 2 boxes. So when I do that, and I look at this component, basically what we've done is we've placed this geometry in every single box, right? We're going to do this for the flat one as well. So I'm going to place all of them in the box. So now we have the sort of pushing up version and the flat version. And what we want to do then is we want to blend 2 meshes, another Pufferfish component. That's going to allow us basically to go between them. So we're now going to have to join these guys, right? So they're all separate. And we want to join mesh join 1, mesh join 2. And so now I'm going to join, basically I'm going to blend mesh A with mesh B. And then we have our factors. And in this case, the factors are controlled. We can control them similar to what we did before with a pull point or like a closest point, but this time we're going to do pull point instead. And yeah, let's go on with that. Just doing it correctly. So what we can do now, because this surface is curved and it's a bit harder to put like a curve on this, it can just be like a bit of a pain. What we can actually do to change this is we can take this right here and we're going to do create UV curve, right? Select points and other points. We're going to do that. And then if we go back and look at the UV, it has now placed, like this guy, it has now placed here this basically rectangle, which represents the surface, right? You have to imagine you take the surface and unfolded it and placed it flat. And so what we can do instead, for example, is that we can swap this so we have a bit more vision. We're going to take this curve, set one curve, and we're going to use this as our reference surface, right? So now we have a grid on this. We have our two different structures joined up. And we are now going to place, let's say a curve or something else, but we'll just put down, for example, like a circle. So put another circle and maybe I'll sort of squish it in on this side. Make a little heart or something. Yeah, okay. Like to make some odd shape. If we say, let's say, get this curve into Grasshopper, we're going to do, once again, a form of sort of checking the distances, right? And this time, let's use a different one. So like pull point. So with point, we can pull one to a geometry. And what we want this time is we want to check the distance from every vertex. So we're going to deconstruct mesh so we can get access to every vertex. We're going to deconstruct from the joined mesh so we know that they're sort of in order and that we don't have any duplicates because that's what would happen otherwise. So vertices, 17,000 vertices. We're going to pull all of these vertices to this geometry, right? And so now we have the distance from all these points to this geometry. The difference between pull point and the closest point or curve closest point is that pull point can actually work with any type of geometry. So, for example, if we converted this curve to a surface before and plug that in, you can see now that the points that are right underneath the surface just are pulled directly to it instead of pulled to the curve. So you can have a bit more freedom plugging in different geometries. I think you can even plug in meshes and stuff like that to pull point. So the factors here, as we can see, the factor list blends between 0 and 1. That's really what it wants as an input. And the distances here that we get are 0 to, however far away it is. It will be 0 to 15. So we need to remap these to get numbers that are between 0 and 1. Our values come from here. The source is these bounds, so 0 to 15, and the target for 1 stays the same, 0 to 1. And so now we can blend, you pull these in, and hopefully everything is done correctly. So we have 17,000 in mesh A, we have 17,000 vertices. And so blend factor, one pair of vertices, yeah, one factor for each pair of vertices. And hopefully, basically that means that we are now blending between these two meshes, depending on how close they are to the central object. So if we scale this down maybe a bit, we just get this and just scale it down. We should be able to see it update. So you can see that it's fading out over here and then fades in and then fades out. As before, maybe this this sort of fading, it's very linear, it's like close, far, it's maybe a bit boring. So we're gonna use a graph mapper to be able to control the structure a bit better. So pull this and put this into the factors. Then you can see we can edit quite quickly how far away it is. And so this is really just another method of doing the same kind of texturing, but because you went through NURBS before, you can basically do it over a patch of surfaces in a bit more an elegant way. But now we still have the problem that we are on the flat piece and we need to get it back onto this curved piece, right? So how do we do that? Because we are working with surfaces, we can use Sporf, which is the Grasshopper version of flow along surface, right? Which if you're familiar with Rhino, you might know flow along surface, where you can select two surfaces and sort of blend or like take one and blend it onto the other. And so here basically you have a couple parameters. You have the geometry. So this is what we want to move from one place to the other. The base, which very conveniently here is the curve we selected from before. So I'm going to take this and drag that all the way over here. Hopefully this also understands that a curve is on the surface. And then the target, which is the surface we were using before. The surface that's over here, right? Sporf also needs two things, which are the parameters, which really defines the like UV corner that it's getting set on. The easiest way here is just to set them to 0, 0, and then rotate them manually. As you can see here, it's sitting on the inside. I think if I switch to 1, 1, it might flip. Otherwise, I'll just have to flip the UVs of the surface. Or flip surface. Does not seem to like 1, 1. So let's just go keep it 0, 0. And we will instead take the surface and do flip, which hopefully is the surface. We can just flip it. It's not. Surface UV. What is the component to flip the surface UV again? Surface UV. In Leo finding it, I might just do this, flip it in Rhino, and hopefully that should. Oh, maybe not. Let's see if I can find this component I'm looking for. Flip mesh, flip power surface direction. There is definitely a component somewhere. Maybe in the analysis tab. Surface domain, degree surface, evaluate polygons to construct. UV. So guide surface. There you go. Reverse surface direction is what I'm looking for. What are you part of? So this is part of, I believe, a lunchbox. Say flip. If you have lunchbox, then great. If not, then it might be time to get it, unfortunately. But this should reverse it. If I am reverse option, 0 do nothing, 1 reverse. So let's go, let's just put in 2 and then we can cycle through the options. There you go, 3. So what I need to do, it needed to be reverse UV. And that should hopefully, I flipped it. What you can see as well here is that when it did flip it, I believe our grid structure, because you've shifted U and V, is also flipped. So we probably want to go with the opposite that we had before. So not 35 and 14, but 14 and 35. We're just flipping it over. So yeah, but now that we are looking at this, let's have a custom preview and have a look at the actual structure. Fully rendered out so we can see what's happening. So we can see that there is an unevenness in the density, right? It goes from quite lax to being really dense, and then quite lax again. And this is due to the grid of isocurves in the surface that you can see here, and how this thing is structured. And to make this slightly better, what we're going to do is we're going to take this surface from up here and we're going to rebuild it. And that should basically rebuild surface. You take the surface and in, let's say, count U and count V, we can basically select how many divisions we want in U and V. And we'll see if that actually fixes the direction as well, or if it, now we're still gonna have to pull it to reverse. And so now, hopefully, when we look at it, let's see if it did indeed fix it. And yeah, as you can see, much more uniform because we've rebuilt the surface. And so our degrees in U and V are now much cleaner. But you can sort of, mess with it by moving these things over. But what I do also see is that our blend hasn't really carried over. So let's look at that. So it looks like it is working, but maybe we want the target, probably want it to be flatter for a bit longer. So that seems to have bolstered the upside. Maybe we'll do we go. I don't want it to be more flat and then accentuated. Hopefully we will be able to see, but there's flatter edges, and then it goes up towards center. Well, actually, you can see it fades out quite a bit over here. It just becomes so white that it's almost impossible to see. And you could always, I believe you should be able to, maybe we can also flip instead the the base here. It's also an option instead of reversing. Yeah, it does the same thing. You can reverse either the target or the base. But yeah, so you get this pattern through a bit of a different method. You still end up with a mesh. I would say the downside with this method, it works really well if you need basically if you need like a localized pattern, right? And your goal is not necessarily that this thing is going to become anything that's a closed mesh. It's purely like, you know, you're making renders for a project, or it's a project that's going to stay on the computer, right? Then it is quite useful. But as you can imagine, because this has now a very complex mesh structure, unless you match it with the one next to it, you end up kind of having issues. So it's good for, you know, if I'm swap over into rendered view, if I look at it like this, then obviously like it fits in and it works as an item, but you can't join these two elements, right? Because at the moment this is a NURBS, and this is a mesh. And even if I went back to subd and then went to mesh, it's harder to join these elements together. But it does allow you the freedom to sort of work on a planar surface. And maybe that is sort of like beneficial to you when you're prototyping or mocking up something. Check how we are on time. Okay. So there is a way to get this to join back in, basically. And I have it I think modeled out down here. But as you can see, you know, definition size wise, you have to add quite a few components. And maybe I can show you this now. I don't think we'll be going into it in this webinar, sort of explaining the bits of how to get these things to join up. Unless we have a load of time at the end, because they'll want to be able to spend some time doing some more curve projections and doing some rendering. But let me see if I can show you guys just really quick what the sort of conceptual side of it is. So you can go over to shaded view and show the elements in this. Ooh. Okay, so to basically join a mesh like that is to some respect like discontinuous with the rest of your geometry. The method that is in these webinar files is basically to, you know, isolate the face that you're going to be working on, and by a process of sorting out and selecting sort of the the inside faces, you can get this edge loop here that is at the most extremity of it. And you basically run the same process that you did for the first twisted boxes. So creating a twisted box for this rim. And so you would have, your inner pattern, your inner two patterns, and then at the edge you have a pattern that I would call a reduction pattern, right? So a pattern that goes from 4 faces down to one face, right? So for example, here, because the structure is made up of 4 faces on each side here on the edge, what you would end up doing is building a pattern that goes from 4 to 3 to 2 to 1 and to have one face, so that when you're rebuilding your structure, effectively you can pattern in different edges, right? So you could come here and pattern in a reduction face on that sort of relief edge. And then you can create a joined structure where you have a very large amount of detail that is non-grid based, or non sort of, based on the mesh grid. You can have something a bit more special. And then you have to have this reduction face to be able to bring it back over. So yeah, the items here get a little bit complicated, but it basically just to point out that it is possible to bring sort of these more high density elements back into the other faces if you really wanted to. But again, is it worth it? That is up to you and your schedule. Okay, let's get into some line projections, some curve projections, because those are always interesting and fun. And so that we can get into some quick inflation simulations in Blender afterwards. All right. So what I'm going to do now is I am going to basically come in and let's say select something like this. I'm going to select this section here and choose to work. If that doesn't go anywhere. Okay, whatever, we're gonna, doesn't want to paste today on those days. Gonna just get this guy over, and I'm just gonna delete everything but this has to be like this today. There we go. I'm just gonna get this edge here, this little last balloon that we have. And we're going to work on projecting curves onto this and making them flow sort of along this surface. So what we're going to build first is we're going to use Parakeet to get ourselves just some patterns that we can project onto it. So Parakeet has a bunch of curve tools that are quite interesting. I am going to pick one that I quite like, which is the floral pattern. So I'm just going to move this actually back to probably the origin. Let's move this guy over here so it's a bit easier to work on. So here is basically just kind of a standard floral pattern. And what we're going to do now is to project this onto this body. Similar method to when we were just working Pufferfish, we're going to use Sporf to basically take this floral pattern and wrap it around like a cylinder or a sphere and then project it onto our mesh. So let's get this one, which is currently a sub D, which is basically a mesh. So we've gone that into Grasshopper. We're going to do sub D to mesh, mesh from sub D. We have that. And we are probably don't even turn it into mesh quite yet. We should take this and make ourselves a little bounding rectangle, right? So rectangle that is sits around this mesh. And what I'm going to try to do now is build a cylinder that sits on this, right? So I'm going to want to get the points that are at the back and front of this box. So I'm going to do deconstruct brep. Take this box and say, okay, here are our faces. Go list item to pick out the items. So already good. First one's the front one. Seems like, and so we just need to find which index is the back one. Probably going to be like, okay, 2. So basically we know that we need index 0 and 2. So now we have our 2 items. And I want to get the centroid of both these. So I'm going to get the area. So now I have, hopefully it's hard to see, but there's a point there and there's a point in the front. And I should be able to do, so a cylinder needs a base, a radius, and a length. If I do, I now want to basically build a base, right? A plane. And I should be able to do plane normal. So that needs an origin. So I'm just going to pick out the first out of these two. So list item 0, that's one of them. That's my plane. And the z-axis, I can do vector to point. So I can take point 1 and point 2. So I'm just going to click here to get the second one. And then I can get A and B. So now we have a vector that's going from vector display. Let's see if you can see it. We have a vector that is going from the first point, right, to the second one. Going straight through here. Might be hard to see, but maybe I can do. I'm gonna remove that. Trying to see, you can remove this, the face colors. I think it's in the sub D, it's in tools. Sub D, edit tools. It's not gonna let me. Anyway, we'll just have to have them colored. It's okay. But you can see a vector that goes all the way to here, right? Going from the start to the end, straight through. And so this is now our z-axis. Now, hopefully, if we plug this into the base, we should now have a little cylinder pointing the correct direction. And now, technically, if we also just got the area from these guys, if we take the area as our radius measurement, then it should cover the entire thing, right? Because we were using a bounding box. And so the area, right, you have to do the square root of it. If you do the square root of the area, then that should be the right size. So that fits, basically just covers this box, I think, right? And a tiny bit more probably, but just enough. And then the length is the length of the line we built, or the length of the vector, which I suppose is here, length of the vector. So now we have a nice cylinder that covers perfectly our item. Okay. What is all this for? So as I said before, what we're going to do now is we are going to basically get our floral pattern. We can get a rectangle that sits around it. The bounding rectangle, sorry, bounding rectangle. Bounding rectangle sits around this guy. And if we now do sporf, we should be able to take this floral pattern as our base, as our geometry, sorry, the bounding box as our base, the cylinder as our target, and then we keep putting our parameter 0, 0. And now basically, as you can see, we have this pattern around. And so now what we're going to do is we want to project this pattern onto our geometry, right? And so how we're going to do that, we're going to do brep closest point. The benefit of having a sub D is that Rhino has a very, very easy time converting from a sub D to a mesh, but also to a brep set of polysurfaces, as you can see by sort of the bounding. So we should be able to now take all these curves. We're not going to do explore, we're going to do divide curves, so we get a bit more resolution. And divide these curves. I think it's going to do by 10 as a default, which should be okay. Take these points, and then we're going to feed our sub D into the brep, which hopefully should work. Otherwise, we might have to just fiddle around with it for a little bit. So now we have curves on the sub D, or we have points. Now what we would do is we would go interpolate these guys. And now we have curves that are projected onto it. All right, pretty nice. If you want to visualize these, there's a bunch of options. Multi-pipe is one of them. Multi-pipe basically just tries to make sub D pipes out of stuff. It does kind of freak out sometimes with really small curves, so it might give you some jagged results depending on your scale. Yeah, but here you have basically an option to get some interesting curves like a floral pattern or any pattern that you choose onto a mesh or onto sub D. Jawad asks, why didn't we use closest point on the previous example too instead of unwrapping the surface? So on the previous example, so you mean with the with this guy with the pufferfish twisted boxes? The reason why you don't use like brep closest point or something like that. I mean, we use a version of closest point. We use pull point, right, to get the sort of the indentation. The reason you can't use closest point to sort of wrap it onto the surface is because you're working with a mesh, and I suppose you could take the entire mesh and like project it onto the surface, but then you would lose that subtle sort of Z height difference that makes the pattern visible. When we're projecting these curves, because we're then going to go and multi-pipe them or like add thickness back onto it afterwards, it's much easier to just project them flat and then add thickness afterwards, right? Does that make sense? Okay, cool. Yeah. So really the difference is that like if you want to preserve z height, right? If you want to preserve any type of depth that you've constructed elsewhere, you can't really project onto it. You have to sort of morph. Whereas if you're building something that doesn't have any z height to begin with, and you're adding it on back like afterwards, then it's okay to basically project on and then make the curves afterwards. Yeah, so that's basically a very simple version of cylindrical projection, right? And as with all things, there are many different types of projections. So this time we did a cylinder, but we could just go in here and put in a sphere. So this is just the standard Rhino sphere. We're probably going to want to get, if you get the bounding box, we're going to want to do volume instead, so we can get the centroid of the entire thing, right? And we can put in the centroid as the base, and then we're probably going to have to do the cube for the volume, right? Yeah, so like the cubic root, cube root, to get the volume down to, not that it really matters, but down to like I guess the cubic root is slightly small, but we can just multiply it slightly. Multiplication. Should multiply this a tiny bit to get it up to what it's supposed to be. 1.5. And so if you have the sphere, you could, because a NURB sphere is essentially just a surface, you can see the line going down here from top to bottom. So it's one big surface you've wrapped around. You can just replace, the cylinder here as the target with the sphere. And so now you've wrapped it around a sphere. And so now you'll have the pattern coming around in a different method, in a different way. Divide it up, project it on, interpolate. And so now you have, again, like a different type. And you see here now it's freaking out a bit more because it's getting some really, really small components, small parts at the end here. Basically, you have a bunch of them wrapped around themselves. And so maybe here, you want to use one of the mesh pipe components. For example, parameter mesh pipe. And so here you could take this curve and make some meshes out of it instead. It's a bit more jagged, but it does also work. And so here there's a whole world of exploration you can do with basically all of the multitudes of patterns and of shapes you can generate with Parakeet. You have a lot of options that you can work with. There's a bunch of Escher tilings. There's a bunch of stuff that you can do. One thing that I wanted to show you as well was what if, for example, you don't have access to, what if you're not working with a sub D, or your thing's very, very subdivided already, so you don't want to go into sub D. For example, if you just have the mesh, right? You can obviously project onto meshes as well. Mesh closest point is one of those items that you can use. And it works in much the same way, right? So you get mesh, you get a point, and they're scattered onto your mesh. Not a very dissimilar process. They can be a bit annoying sometimes because, as you see, it will pull it to the actual grid of your mesh, right? In a lot of cases, it can't really define that often, or it has an issue with defining sometimes the points. If they're close to a vertex edge, it will sort of wrangle your curve to be a bit more defined onto the edges, which is why I sort of prefer converting to sub D, because you'll get it onto the surface a bit more cleanly, so to speak. This can obviously be solved. Like if your mesh is dense enough, you can basically get this to not be an issue. And because it's projected onto sort of a densified mesh version of your mesh, you don't actually have to export the dense mesh. It will still work. And so the difference here is negligible, basically. Okay. We'll be able to print in one piece the pattern on Parakeet if the branches do not always connect. Good question. The one of the ways to make them connect, right? So yes, so because of how curves operate in, I think, almost all of the 3D packages, curves have, or like curves and lines have start and end points, and are not able to like bifurcate. You can't like fork a curve into two different curves, and have that still be counted as one item. The way you would basically get these to become one is, multipipe does a relatively good job to do these, to convert them. The other option is a plugin that I didn't specify for this webinar, so you don't, like, I don't know if people have it, but Dendro is one of the options. So Dendro is the sort of VDB, the volume option instead of Grasshopper. What you can do with Dendro is basically create volumes, right? So what you would do is you could, for example, do the multipipe, and let's say we took the multipipe and made it into, for simplicity's sake, I'm gonna actually copy this and this. Obviously, this is not included in, well, you might not have Dendro installed, so I apologize for that, but it is sort of one of the solutions where you can make this into its own item. So here you go. You have a mesh, and so basically you can say, take this mesh, plug it in here. You have a collection of meshes, really. I'm going to flatten this to count it as one. And then settings, I am going to make the voxel size quite big to start with, because I don't know exactly, don't want to make everything very, very slow, which I might already have. Yeah, so now we've made the mesh into a volume, and then we should be able to go basically the other way around and go volume to mesh once we've done that. And if we put in another size, might make it a bit larger just to it seem a bit slow. So invalid mesh. Volume is 100 different volumes. That's not what we want. We will do just combine and clean, which is a nice component from Kangaroo, which should, even though they're dissimilar, hopefully just count these all as like disjointed meshes, I believe. Yeah, so that's one mesh. All these guys together. And so here the voxel size this time seems to be too low. It's probably my output, maybe. There you go. Now it's coming back in. So here we're starting to have a volume come in, basically with all connected items. I think it is missing quite a bit. So you definitely need quite a bit of resolution when working with Dendra, which is the sort of the issue with all VDB-based solutions. But again, this is really only necessary for if you want them all to be one piece. One Dendra setting, one mesh. It does seem to not like some of the stuff here. Volume settings, bandwidth, desired box array value. It is also possible that it wants here. Yeah, okay. It's possible that it doesn't like the fact that the multi-pipes were not closed. Sometimes they're just like tubes, which means they don't count as mesh volumes. Like they're just sort of uniform surfaces. Yeah, that seemed to solve it. Now they're closed, so it's much more sort of enjoying. And then you can see that these have become meshes that are, somewhat enclosed. So that would be that would be one way to get yourself a whole mesh, right? That you can do something with, print and etc. What I would probably recommend is, if you took this, now I've baked it, but either probably reduce it afterwards to sort of get less, or you can do quad remesh in Kangaroo, or do it in quad remesh in Rhino, or do it in Grasshopper as well, and that'll give you a mesh that is cleaner to work with, and just sort of nicer overall, frankly, instead of being a mess of triangles. Get something that's quads. Okay. We have about an hour left, which I think we're going to dedicate to some last bits here in Grasshopper, and then head over to Blender again to do some rendering and some texturing. How is everybody feeling? Do people want another break, or do you want to push through and finish out the hour? Okay. Walter saying quick break. Let's do like a 5-minute break, if that's okay with everybody. Just grab a cup of tea or go to the bathroom. So we'll reconvene at 5 minutes from now. All right, guys. See you then. Okay, everybody. Hopefully everybody's slowly trickling back and feeling all right for this last hour. Okay. We've covered basically most of these methods. There will be some more variations of them here out on the left. But for the most part, we're basically there. The only last thing that I wanted to cover on the mesh patterning front, which I'll go back to really quickly until we jump over into Blender and do, I think, good sort of 45 minutes over there, is if you are working on these meshes and you're feeling that you're working too much with like a grid and you don't feel like you can like really break out of this grid or getting patterns that you think are interesting, it is possible to sort of like shift your reference grid, right? One way to do that would be using the tilings from, I believe, Mesh Plus. And so these guys take surfaces that they want to mesh. Correctly, let me just check. Yes. And so what you can do is basically take a mesh and transform it to a poly surface. So for example, mesh to poly surface. Might reduce the, okay, that wasn't, I think it did not enjoy that amount of data. So I think once this unfreezes, I'm going to reduce the amount of faces. Come on now. Okay. Ooh. We're back to being small. Let's wait for it to process all my old inputs. So it was good. Okay, thank you. Come on. Okay. Hold this down to like 2. Hopefully that'll be a bit faster. And we're going to do, so we now have a bunch of poly surfaces, which we can plug into this diamond tiling, hopefully. Here up to surface, so we should actually be able to do probably a mesh explode. Take this, take every mesh square, transform them into untrimmed surfaces that we now have, and then it's going to try to do diamond tiling, which is kind of overdoing it. So what we're going to do is we're going to basically put 1 into U and V. We only want 1 tiling. So what we end up getting is just basically an X, or like a square within a square, right? So we have our old tiling, and then inside of it we now have a rotated square. And what we're going to do then is we want to get rid of the outside square. So we're going to do mesh naked edges, I believe. No, we're gonna do, what's it? Is it mesh edges? Yes. So mesh edges. Get a mesh. And we can get the naked edges and then the interior edges, which is really what we're after here. So if we look at these and look at the curves, right, we now have like this interior surface, which is a square grid, but rotated 90 degrees basically from the original tiling. And if we have this one and we do weave back from lines correctly, then we can basically create a secondary mesh. This is similar to if you're familiar with Maya, when they have I think poke face in Maya, where you can add like a middle and then through some selection wizardry you can remove stuff. And so here I'm probably going to actually flatten, if I remember correctly, and that should give me all of them. I'm just going to hide some of this stuff so we can actually see what we're doing here. So the other problem you end up with when you've done that is you basically end up with these gaps. Because you changed the topology, you've ended up with sort of like some square-sided, some five-sided gaps that you need to fill in. Luckily for us, we can do some mesh naked edges. This time it should be this. And we should be able to get, it's always this. There we go, mesh naked edges. Can get all of these holes, and then we can do, I believe, mesh fill holes, which is another mesh plus component, if I remember correctly. And here we have our options of the curves that we're going to put in. And so here we go, filled holes with triangles, which means that your patterns that you put in are going to be slightly modified because of these triangles, but you can sort of do your best to avoid them or swap around some things to make that work. If this is if you're sort of concerned with your geometry looking too squarish, you can always tilt your axis basically. And now you can just let's do combine and clean just to make sure that there's no funny business happening. These guys get our woven back mesh from here. And now you have a new and different tiling, right? And these guys are all probably need to be flattened so that they're encompassed in the same area. And there you go. And so now you could take these, for example, and plug them into here. And so now if we look at hopefully the tiling we get, see if we can see it, or if we have other stuff in the way. You get a slightly different look than before because all of your items are tilted basically 45 degrees, which can give for sort of a bit more of an interesting look in certain areas. Perfect. Yeah, hopefully that's somewhat clear. You can obviously do this with other ones as well. You can get the meshes dual, which some of them have. Otherwise, we can do somewhere else. I think dual topology, topology of this dual. I don't know if this is n-gon or if it's in, yes, n-gon. Yeah, these get into when you're doing the dual, you're usually getting it'll give you like the hexagonal version of it. Type P as list, which sometimes Grasshopper is not so happy dealing with ngons as it is happy dealing with other, I don't know if this will actually work. I can show you later in Blender. Yeah. So basically just a way to shift over your look. Now, let's get on to our last bit, which will be bringing some curves and some items into Blender and doing some interaction through inflation and through like simulations. So what I'm going to do is, just for the hell of it, I'm going to try to get, maybe I'll swap this guy back to whatever we were working with before. It was the start points rather we're changing here. This guy's going to change it back to these start points, so we get a bit less of them. So we're going to start baking some stuff and bringing it over into Blender for our last bits, basically. I'll bake that. I'm going to take this mesh we made here. So this guy, bake that. Bake invalid blocks. It's an invalid object. Let's just clean it up with combine and clean before we bake it. Should be a bit happier that way, I think. Invalid mesh. And we'll bake it. We'll see what happens. I reckon it should be fine. I think it's whining about nothing. Okay. Yep. Okay. And then we will, in the case of this last projection part that we did, we're not going to take either the pipes or any of those. We're actually just going to grab, we already kind of have this inside of Blender. We have it on the other part. So we're going to grab just the projected, the interpolated curves, which I believe are these. And we're going to bake these as curves. There we go. So I have my 3 items. They're in a bit of a sort of concoction now, but we're going to export all of these, and we are going to export them very specifically as OBJ with the option to allow for NURBS, which OBJ has, which means that you can actually export curves through OBJ and not have them transform into meshes. And this is useful primarily for us with software like Blender or Maya or even Houdini, where you're able to take advantage of the properties of a curve as like a more reduced item. So here you say save surfaces, polysurface, and extrusions as NURBS objects. Save surface trim curves as curves, and click OK. And that way we have all these items exported correctly. So that should be that. And we should be able to jump back into Blender. So where we left off, let's import some stuff and get started on understanding some texturing and some rendering. Okay, so actually I think the OBJ, it only takes one of them at the time, but either way, we have our curves, which is good. We're going to take all of our curves. So I didn't want to, and Control J, which will join them all into one object. And I'm going to go back to Rhino just to export the other ones as meshes separately. Didn't actually know we wouldn't do both at the same time, but guess that's life. Yep. Okay. We're selected. Go finish it on it. See if that did the trick. Import obj. It wasn't finished exporting, was it? It's let it pop up with the menu for me. There you go. Polygon mesh objects. Okay. Okay. Take all this. Remember to scale it down 0.1 times. Luckily, our objects line up. And then in Blender, a very handy feature, you can select all the connected items. So if I select the top here and I press Control L, I can select all of the linked items, all the connected ones. So I'll be able to get these. I can maybe make them probably RX, what is it, 90, right? So 90 on the x-axis. I'm probably also going to move them down a bit, but primarily I'm going to press P and separate by selection. So I have two different objects. I can scale this guy up and sort of layer it how we fancy. Right. And then we still have this guy, which we're going to also scale down. And this one was, I believe, taken off of a copy of this. So we're going to move it out. Obviously, if you were doing this on your own, I would recommend not moving your things as much so that like when you import and export, they are always at the same location. Because I'm doing this as a webinar, it's a bit harder to be as diligent, if that makes sense. You can see that the geometry sort of center is over here, and so I'm going to press either for you it might be Shift Space if you're not sort of set up with Blender the way I am, or Space to bring up the search menu. It's most likely Shift Space, and you can do Origin to Geometry, and so now the scaling will be a bit easier. So what is the last step that I want to do here? So I want to do some inflation on this part so that I have some interconnectedness between this bulb underneath and our pattern that's sitting on top. So what I'm going to do is I'm going to go into here, select right up about here, right? I'm going to copy this. So I have a different one, press escape so that it's at the same spot, and press P so I can separate the selection. And then I'm gonna hide the original body. Oh, yeah, forgot to do, as you can see, forgot to do press Alt Z so I can see through, so I can see all of the points and get a better selection. So Shift D to duplicate. Now it's moving with you. Press escape to put it back where it was. Press P to separate by selection. And now you have your own item. So now I have my own item. What I'm going to do now is these curves, they're now in Blender. I'm going to thicken them here in Blender. So I can extrude, but it's actually not what I want to do. I want to do here in the bevel, I want to do depth. So I can get these to be meshes here in Blender. And I'm going to put on fill caps. It makes them round, but I can probably fill it with fill mode. That doesn't really matter. We're gonna leave them like that. And so I've filled these items, made them into sort of their own curves. As I showed, the way with Dendro would probably be like a slightly more optimal way if you're working on getting a unified mesh, but this works as well. So now we have this sort of outside geometry, and we have an inside one. What we're going to want to do is, because this is a curve object, not a fully realized geometry, we're going to convert it to one. So I'm going to duplicate because I want to keep a version of my curves. Duplicate and hide those. And then what I want to do is in my object, I believe it might actually be if I open it and do, I'm trying to find the setting here. I never used the setting up in the top. And it should be an object convert. There we go, object convert to mesh. And now it did it just as quick as I typed it, but you can see that now this object is a mesh object. And so now because these are two mesh objects, they can interact. So what I'm going to do is I'm going to go into our copied object here, select all of it by pressing A, doing Alt S so I can scale along the normals and scale it down a bit. Not too much because otherwise it will start overlapping with itself back here. But I wanted to scale down so that it's not initially touching the edges. And then I'm going to go into the physics tab down here. In the physics tab, I'm going to define this item as a cloth, which, okay. We might also be, you might want to switch over to the timeline editor. You might not be at 0. And so it might already want to sort of have started to do its cloth simulation, which is not what I wanted. But yeah, make sure you're back at the start. And then this one will define it as a collision object. Now we can check that all these things work. We're gonna probably need to move over this thing. We're gonna check pressure because we want it to inflate into the other one. Internal springs, we don't really care for now. Damping, tension, stiffness. We can see what happens. So if we then press play, which will be spacebar for you, it should start to inflate. And so we can see that right now the internal pressure seems far too low. It's kind of deflating instead. So let's put that up to like 5 or something like that. Starting to get better. Probably gonna double it or maybe just go to 15. Take a couple steps to so let's see where it's going. I would probably say that I've made these curves a bit thick at the moment. So what I'm going to do is I am going to go back, take this, and then make these curves a bit thinner. This is why I think it's slightly more useful sometimes to do this, you know, in Blender itself, because you get a bit more sort of option to work on it sort of after the fact, right? Otherwise, you're going, you know, if you have enough time, going back between Rhino and Blender is no problem. But sometimes you can find that it's just need to be able to iterate a bit faster. So I'm still going to up the pressure. Ooh, and see, already there went a bit too far. Let's try to go down. It's loving to slip out, which is sort of interesting. We should be able to define that. Collisions quality, shape, pin group. So we're gonna define I'm gonna define this back group as being pinned so that it can't really slip out the front, if that makes sense. And so this is a vertex group. So we can get into the data vertex group, assign all of these to a certain vertex group. And so now just to check if I select this vertex group, and select those, and I should be able to go back to the physics tab and pin these in place, basically. See if that helped. So it wants to do that. I'm probably going to up the collision quality a bit. And probably reduce the pressure because it seems to be just a bit too high. It's snapping into place just a bit aggressively. There's probably a likelihood that it's interacting with some piece immediately. So I might try to scale this up a bit and just have our shapes be a bit different. I know why. Sorry, of course. The reason it's not working is because because I deleted the object and remade it, it's no longer a collision object. So it's actually not colliding anymore. So just inflating on its own. Yeah, so now we'll take a bit more time and start colliding. Things you forget. So it is quite slow. I might actually reduce that collision quality again, just to have it be a bit faster. So that makes sense. Let's reduce our collision quality to 2 and we can increase the pressure again. See how quickly it decides to inflate. Oop, a bit too fast. A lot of this pressure and stuff like that simulations just take a bit of time to get right and to work with. Now we're getting somewhere maybe. What we can see as well is we might actually want to see, is it sticking through? Yeah, it's actually coming through. So I am going to try to scale this up slightly, make them a bit harder, a bit sort of later to interact with each other. And probably up the resolution of this. So I'm going to choose this and go subdivide. Just make sure now that the vertex group is still at the start. The reason I'm upping the resolution is because basically when it was interacting, it was sticking through. And mainly that's because it doesn't have enough collision sort of elements to go by, right? When it's doing this collision simulation, you have to think of it as like it is the only thing it has to go by are the vertices that are present. And so if a vertex basically ends up popping out of the surface, it doesn't really know what to do with it. And I might also edit the speed at which this is happening, but it seems that we're getting slowly getting some good results. It's 2, 3. So what does this look like? So even after like just a couple of frames, we don't need very much. Yeah, exactly. Now we're getting something. So if we now go and put into sort of the auto smooth, we can see that we have interactions between the two. And if we went and put in maybe, let's see if we can do that, a subdivision modifier, we can see that we're getting interactions between these guys, right? Where you have pressure points and low spots and high spots. And so what I am going to try, I'm going to remove the subdivision so it's a bit fast to calculate. I'm going to go back to the start and I'm going to do one more and then try to up the pressure just a tiny bit so we get a bit more of that like sort of puffiness from these. So let's try that. Let's go up to like 30. Maybe the stiffness. We will try stiffness. Maybe we'll put stiffness down to like 12. So we want the thing to be a bit more flexible and for the pressure to push it a bit further. We have to calculate for a couple of frames. Again, we don't need a lot, just needed to have a go. Okay. We got something here, some interaction, which is, I think, starting to get pretty interesting. So let's try and get all of our stuff back. So like if we then went and took this guy, and let's say I'm gonna, just to make sure I'll separate instead of deleting, but I'm gonna select all this. I am going to separate the selection and hide it. So that now, I didn't want to go into the rendered view. I don't know why I did that. Now we basically have this difference of section, right? It goes into this different element that has all these ornaments and an inflated sphere. We have all of our sections. And so let's try, let's try to get some rendering going. So rendering is going to be our last bit, just checking how we are on time. Cool. We have about, I guess, half an hour for rendering. The Blender shader editor. Blender shader editor is in my opinion, a very good editor. So this is the shader editor that comes with cycles, which is what we're going to be using mainly. Blender has a couple of different rendering engines. So it's cycles and it's Eevee, workbenches, which is what your sort of preview is. And then these ones are two additional ones, LuxCore, and this is a CAM one, which are add-ons. What we're going to do is we're going to build some procedural textures to go onto our design, right? When building these, we are going to build them with nodes, similar to how you do in Grasshopper. Blender has a couple of presets in terms of stuff you can do. So you have all of these information, camera data, bevel, attribute, and occlusion. These are all sort of object input data. Outputs, you're not really going to use the outputs a lot. You have color, so these are to change the hues and saturations. Converters, these are like math basically. Shaders, which are the type of material. You can do most of the stuff with a principled shader, but these are useful sometimes. Textures, which are very useful, and then vectors, a bit more math stuff, and then scripts and groups and layers. The first thing we're going to look at, I'm going to hide all these objects just for a second. I'm actually going to put them first into a new collection so that I can reference them real quickly. To do that, you press M, and then it'll bring up the menu. So what I'm going to do is I'm just going to put in a sphere for now. And on the sphere, I have some materials in the file that is included, but we're going to start from scratch. So in your render, if you turn on the render view, it will most likely look like this. It will probably be gray. if you want to change the color, you can go here into here, the world. So this is the world tab, and you have a color and it's gray. Yours will probably be set at like 1, and so everything will be gray. I like to work from everything in pitch blackness. If I turn off my overlays here, which is Shift Alt Z, it's just black. So I'm going to go here, and then I'm going to now add an area node, an area light, sorry. So now I have some light, right? Now some light, and I can play around, and I can know, and I can sort of work on my textures. There is also this viewport shading, which will allow you to sort of view your textures a bit more easily. It can be a bit slow at times, especially if you start using a lot of normal maps. But to start off with, we can go in here. So this principle is BSDF, sorry. You have all of your options. Some of them are hidden, but your base options are here. You have your base color. You click on it, get your options. You can go and slide these to, for example, more metallic. This will become more like a metal. And if you change the roughness, for example, down, it'll become really glossy metal, so it's shiny. And then you can go back up to make something that's more diffuse. The IOR, which is index of refraction, which is sort of more of the transmission and glass related stuff, but also matters for reflection. The alpha, if it's sort of visible at all, 0 alpha means it sort of just doesn't exist. And then you have your subsurface, which is sort of how skin behaves, specular transmission, coat sheet. I assume people have some understanding of this. We're basically just going to jump in and start building a texture. So at the start of the webinar, I told you to go into preferences and turn on Node Wrangler, which is one of the add-ons. Node Wrangler here helps a bit to make things a bit quicker. So if I do Shift Space to bring up the search bar, I can do and go and get a noise texture. And if I have Node Wrangler enabled, I can press Control T, and that will add texture coordinates. And you can leave these on generator for most of the time. Blender does a pretty good job of sort of mapping textures onto your objects if you don't need to UV unwrap them. If I press Control Shift and click, I can take whatever node I'm clicking on and bring it to the material output. So here I can see a noise texture that I can scale up and down. Looks a bit like the moon in certain phases. And I have the detail and the distortion, right? So I'm going to, for example, I like to increase the distortion and get a bit of a higher sort of detail, and then you can get something that looks quite interesting. So if we go to like 3, so that's already producing. And the real power here comes in when you have a noise texture and you use, for example, something like a color ramp. Color ramp is basically a gradient, right? The noise texture can also be seen as a bunch of colors, but we just have black and white. The gradient allows you really to sort of mask things, right? So for example, here I can make certain parts darker and I can certain part lighter. And if let's say I had 2 color gradients, right? And I set 1 to have like a bunch of like black and white areas. So I'm going to mix black and white, and I'm going to get some dark areas and some brighter areas. And I want some like slightly stranger transitions in between them. I want to get some more interesting stuff. Can mask out areas basically. It's very interesting. I'm going to make the scale slightly smaller so we have a bit of a bigger patch. Maybe even smaller than that. Yeah, so let's say we have that. Maybe so let's say, for example, I want the black areas. I'm going to say these represent if it's like really reflective, right? I want the roughness. If the roughness is brought to 0, it's entirely reflective. So I'm going to make these areas. I'm going to make this control the roughness. And then here, I've got myself the same noise, but just color mapped differently. And I'm also going to put in a color ramp afterwards. We're going to change these colors to not black and white, but let's put them at shades of kind of like shades of blue. So we'll do that. I'll put in this, and I'll put in one more color as well. Drag that to the other side and make it some little lighter blue. So let's say I have that. So this one, just look at this, I might do that. Let's see. Probably want to drag this over a bit so it's a bit wider, and then drag the blue over so we can have some blue patches starting to appear in. And now I'm going to take this and drag it into the color. And I still have some lights, or sorry, the alpha, put that up, put it to 0. So now you have a bit of an interesting pattern, and what we're going to do next is basically take this transmission and make it 1. So now we basically made this thing like into glass, kind of. We're also going to put the metallic back to 0 because something can't be both glass and metal at the same time. But so now what we have is like this sort of interesting, if we sort of try to shine some light through it, we should be able to get some interesting see-throughness in certain spots, hopefully. And if we swap this over for a glass BSDF instead, so it works more on glass. Actually, the thing we're going to do for it, if we add a bump map. So what is a bump map? A bump map is basically, if you imagine doing displacement in Grasshoppers, if you're adding texture, a bump map is like faking that, but for render. So you can take your for example, this thing that I've decided to decides my glossiness. Let me take that, and I'm going to use that to be my normal map through a bump map. And so now if I look really close, this texture will look like it is sort of poking out, but it actually doesn't really have any intangible effect. It might be more obvious if let's remove this for a second. If I, for example, remove the glass looking aspect for a second, you can see how the normal map, the bump map, is poking through and allowing you to perceive texture basically and depth where there really doesn't have to be any. And so what I'm building here is kind of just like a icy looking texture almost, right? And if we take this over into a glass BSDF instead, maybe, then it might look even crazier. Let's do that and see what this looks like. Try to brighten this a bit. I shift it around these guys, so it's a bit the opposite. I probably want the lighter. Let's put some darker hues on the inside and some whiter hues on the outside. And now you have sort of an ice with snow on it by just playing around with some noise maps, right? And a very, very quick demonstration. So in this file, you also have, so those a quick description, but there is in here also a sort of glass refraction material that I think is quite interesting as like a demo of procedural texturing in Blender. So as you can see, we're still working with the same just plain sphere as before. And what's been done is I have taken a noise texture and then a second noise texture. The second noise texture, it's really hard to see here, but if you look at the color ramp afterwards, you can see that I've just made it the scale really small, and then made a big transition sort of black to white. I just want 2 areas. And then I use those 2 areas to mix 2 colors. And then for the normal map, I put a noise texture, and then I put some bump nodes, and just mixing 2. I don't know if I'm mixing 2 bump nodes. I think the second one's not really necessary. But oh yeah, sorry. Like yeah, we just have a flat, basically normal map and a bumpy one. And when you combine the 2, you end up with having a one side that's really textured glass, basically, and one side that's not. And in the preview here, because it's using a sort of preview HDR map, it doesn't really look like much, I think. But when you start rendering it out and you look at the smooth side, I have to turn off the denoiser because I think it doesn't like this this look. But you can basically end up seeing these really cool refractions through the glass from the other side. While sort of the expenditure geometry wise is not very big. So just out of understanding those, so like in Blender you have a bunch of these textures, just to go through some of them quickly. The first one you'll probably use as noise. Second is likely the Musgrave texture. I'm going to pop all these in here and just go through some of them really quickly. And then we will quickly texture our objects. Voronoi. Let's do that. I am going to take all of these and just place them here for a second. Giving them all mapping nodes, whereas technically you could just feed the same ones into them. But so if we look here, brick texture, as it sounds, gives you basically a set of bricks. And you can either set them here on the sphere, it tries to pattern them, I think, top down. You can obviously tilt and change the rotation of these textures all around here. So they're just rotating it. Musgrave texture is quite useful for generating stuff like puddles. It basically is the type of texture that water will have. You know, like a water that's quite calm, but still just like the ripples are going up and down. So it's kind of like a culminated noise, like a bunch of noises on top of each other. If you, for example, if we copy this over, we said we put a Musgrave, and we color ramped it to be, actually we didn't even do, we can just do a bump map to make it what we want to use, height into normal. And we put this guy to like something like a blue and a bit darker. At some point it loads in. I might switch it back over to the rendered view. That's the thing where compilation of shaders is a bit slow. But yeah, you can get like maybe increase the scale. On a plane, it works a bit better, but basically it's a type of texture that you'll have on water. Voronoi, if you've messed with Grasshopper for a bit, you're probably very familiar with Voronois. You can get any of these. Voronois in Blender are quite useful when you add them to a bump node because you can get this cell sort of cracked look. They also look quite nice when you swap over to the so non-Euclidean versions where you can get these different cracks. And then yes, that is the ones I would recommend is the magic texture, which looks as a repeating sort of pattern that's worth looking at. So it sort of repeats in this sort of strange pattern. Increase and decrease of distortion. But enough of that. Let's us look at texturing our actual objects. And so we can do a bit of a practical exercise with those. Okay. So we have our stuff. Let's make some kind of texture for this. I was thinking of making some kind of maybe brick-like texture for this. So I'm going to start that by finding the start. If you have the, turn off the blooms I have on here. If you have a full-size keyboard, by the way, and if you get lost in the shader editor, you can always just press the home key, and that will sort of bring you back towards me. So let's get started with some kind of bricks texture. Brick. Put that in here. I think that I want it to be much smaller than that. So we're going to take here at the scale. If you want to edit all the scales at the same time, you just hold and drag, and then you over all of them. Going down in scale usually makes it bigger, and going up, so putting the number higher makes it smaller. We probably want to land somewhere around 20 or maybe even less. 10. It seems like it's applying it like top to down, but I think that could be kind of interesting. So we have a bunch of bricks, and they kind of get stretched out up here, which I'm not the biggest fan of. So maybe we'll do them. Maybe we just rotate a tiny bit, and then that should be fine. There'll probably be somewhere where it messes up, but I don't really mind. Let's get that. So we have all our bricks. They're all black. They're the colors here. You can either edit as white, black, gray there, or what I'm going to do is put in a color ramp, and you should be able to edit them here as well. So I'm going to put here, and I'm going to say the bricks I want everything to be shades between somewhere in brown like this to somewhere in a lighter, maybe yellowish. Too much. That might be interesting vibe. So what I do then is I think that like the brick might be just a bit too normal. And so I'm gonna stack it with a Voronoi texture, I think. See what that gives. So the Voronoi here doesn't do much. Maybe we can do the opposite, where we get the Voronoi first. So 1,000 little patches, and if we apply brick to that, it's possible that the bricks will be based on, I'd like it to be based inside of the pattern if that works. I'm not sure it loves it. That's quite interesting, but it's not really what I'm looking for. Just gives it a very Voronoi look. So maybe we keep with the bricks, and can we, let's make them a bit larger and maybe feed them into a noise texture. Could be something. Okay, the bricks really just need, the bricks really love to stay bricks. What I might try then instead is we're going to build this from a Voronoi texture. So I'm going to take these bricks away. And really a Voronoi, if you decrease the, should become sort of square-like. So you can see it snaps kind of to a grid. And so I think we can make this a bit sort of nicer by going for one of the odd ones, adding a bit of randomness. There, maybe we'll scale it a bit differently in a different axis to get some kind of oddity. The patchwork of things. And really I'm gonna want this patchwork. I want each individual tile to be individually colored. So there we go. So now I've managed to get sort of a brickwork that is a bit more different. And I think I'm going to scale this up. So I'm going to go into like 7, right? And then what I'm going to do is I'm going to get a bump texture, bump node. And I'm going to take whatever we have. So probably the color, plug it into the height. And now we can make the boundaries between these areas much stronger. So now you can see we've almost created like a pseudo, pattern on here. And I am gonna probably choose to subdivide that one out if I can. See if it works. Subdivisions, it's a bit rounded. I think that'll make it a bit more interesting. So you can see also, I think that these currently are not merged together, which actually might be good for us. I am going to do something that I think might be a little bit interesting. I'm going to go in here and I'm going to select the face, Control L, and I'm going to split this body. Sorry. And so now I actually have 2 different bodies, and I'm going to take these guys and color them slightly darker. I will probably remove, you know what I will do? I'll go in here, I'll select all of these, and I will select loops, select the boundary loops. So these are all the non-connected edges. And I'm going to choose to crease all of these. So now these guys will stay sharp, right? I'm also going to take all of these and they'll have diffuse 0, but I'm going to click this button and do new material, which will duplicate this guy. And I'm going to make these like something darker. Maybe we switch, like, we do the opposite colors. We get something like slightly blue. And then because we have all the edges selected, that should be fine. We can now do Alt and then merge by distance, which should connect all these. So now if I swap out, they're all connected. And because they're all connected now, I can do select boundary loop. So now we should get all of these edges that are unconnected. And maybe I will do select more. Actually, I'll do this and then swap over to, I won't like it if it's okay. Not swap over to face. I'm going to stay here. I'm going to do select more and then swap over to faces. So now selected like basically all of the faces that are connected and at the edges over here, and maybe make a new material here. So you can have multiple materials on one. object. So make a new material, and I'm going to make this like a glowing material. So emission, strength 1. I'm going to make it like blue. I'm going to make this blue as well. I'm going to assign it to all of these faces. So now we've got sort of a patchwork, I think, and it might be quite interesting. You know, there's areas that are like this emissive blue part, and there's areas that are darker. We're starting to get something that's looking like something. And so because they weren't connected, I can now get like this nice transition between two elements, right? I have this sort of harder pattern, and then it swaps over into a different color, but still the same texture. I think could be quite interesting. So that's one little part done. How about we try our hand at the inflated part here? I think I want to do something vaguely similar, tying the two together. It's getting a bit slow. So let's try to do something vaguely similar. So over to maybe the shader mode. Okay. I'm just gonna actually hide these for the moment so that I can work on one without getting slowed down. So let's, for example, say this blob here, we want this to be a new material. And I'm gonna say, I want to do something based on the geometry. So you have this option for pointness, which basically what it does is allow you to check how curved an object is, right? It's curvature math. It's often kind of just turns out to be very gray and not very visible because your pointiness in all the grand scheme of things is not very high. So you kind of have to put a color ramp to get these shades to show up. So do that. And I'm going to try to affect, I think also probably some sort of glowiness, right? So let's make this material up the weight. So transmission to 1, I'll make it a bit blue to fit with the other part. And then I want, it's making it, so right, so sort of blue opaque bit. And I'm going to make it so that we have an emission whose strength should be based on this, but probably with a we're going to math node and multiply it. The emission usually needs quite a high sort of, how to say, a high value to start high strength. So we're going to do this value here. Color should be, I don't know, something in the bluish region. Maybe we'll make it purple. Okay. Real slow. Maybe we'll have to turn off the render preview so I can. edit. So turn that to purple. And that should do the trick. So we're looking at basically having the pointness drive our emissions. So now it's everywhere. So we're probably going to need to, yes, it's currently on add, which now we want multiply. That's why it wasn't working. And we will probably swap it around. Am I wrong? We want the major parts to be black and then a very, very small segment to be white. So now we can see we have some very tiny areas of purple shining through. And this will be accentuated if I turn off the lighting. Should be able to see it a bit more. It's not a very high resolution sort of map at the moment. If you both shade smooth and add a subdivision modifier, it should give slightly cleaner results. Because this calculation is made render side and not before the render, so it's not really possible to use it. Yeah, now we can see that if we probably back off the darkness slider, the control. It's very, very touched up. Yeah. So maybe now if I turn back on the other ones, we get a mix of the two geometries. And then turn on some lights. Ooh, maybe decrease the brightness on those lights a bit. I have two lights in there. Oh, that, yeah, this is the one that's exceedingly bright. Yeah. Maybe add a little bit to this, and I think we're gently reaching the end. If there are any questions about this, feel free to pitch in. Otherwise, I think we're gonna wrap up soon. Should make this into a metal. See if I can sort of tie the room together at the end. Yeah, but like Blender's the way Blender handles bump nodes, especially, I think is often very sort of makes things very easy. If you have this Voronoi and the colors are slightly different, it will accept it as different heights in the bump, which makes that it looks kind of like flakiness, or it looks like they're sitting on top of each other in quite an easy way. So I very much recommend experimenting with the Voronoi options. Both the Chebyshev, Manhattan, all of those give sort of quite interesting results. And you can really play around with stacking them as well. Is there a graph mapper to move the density around? I don't necessarily think so, to make the flakiness appear different. What you can
Yeah,
do,
sure. I think you should, if you want to stop the rendering, because it's like breaking up your voice a lot, for answering the questions if you want.
Oh, sorry. Is this better?
Yeah.
Yeah. I think, yeah, let me check. I can probably show it just in a preview like this. But yeah, there are ways to make the Voronoi density spread out. And I would say sort of if we popped on a Voronoi texture and we do a noise texture, normally we should be able to sort of get these two to play nice together. It's not always the case, but if I do this just so I can see noise and then a Voronoi on top, sometimes you're able to get these to work. So often you'll get these guys. If I can, let's see if I can. It takes a bit longer to compile, but you can't quite get the Voronoi to shine through exactly, but you can get these sort of structures. And I guess if you go here to maybe Chebyshev or Mahan, it should sharpen up a bit. Yeah, so they sharpen up a tiny bit. And I suppose you could, maybe it's if you decrease detail on the noise, you can get some more sort of blocking, right? And if you then feed these into a bump node, and look at that as like a holistic thing, then I think you should be able to get some sort of not exactly graph mapper like, you don't have a perfect control, but you can get larger blocks that you can play around with, which can definitely be helpful. Try to feed the colors through as well so we can maybe see something. Some very kind of interesting, non-traditional patterns. And if you color this in a more uniform way, you can get it to look pretty good pretty quickly. And obviously, if you can sometimes it's nice if you can just use mixed nodes. So for example, if you took this noise and just scaled it and added some, distortion, saw that, and let's say you made it a color mix, and you made something like darken, just like if you're familiar with Photoshop, you can darken, lighten, do all these things. For example, shove one into there, shove it there. Like this, I don't think it looks like much, but I think if you plug it into here, you can add a bit more texture. And especially if you decide to take this combo and pour it into probably a bit too much, you probably have to play with the factor for that. Maybe we take, that's this one, that should be A and B. There you go. And so now you get sort of a darkening on top. Maybe you can play with the blending modes. We have like color dodge or something. And so you have the texture pop out more in the lighter areas rather than the darker ones. There's obviously like a sort of a million options here of combining and layering and stacking and getting something that becomes really, really interesting. Bring this to a metallic maybe. Thank you so much, Walter. I hope all this was useful for you guys. Let me actually save all of these files and upload them. And that way I can send that over in the chat and hopefully maybe share it elsewhere as well.
Can you put it in that same
yeah, just put it
folder?
in the same drive, I think. Yeah, I'll just put it in the same drive folder. So hopefully people who already have the link,
Yeah.
just go and have a look there.
Yeah, I think people should just save that and then
All right. Cool. I think that's about it.
Well, thank you so much. It was really cool to see how you made this project in that workflow. And thank you for everyone that attended.
Yeah, thank you, everyone.
Yeah.
I'm gonna say, yeah. If you have any questions post this webinar, feel free to reach out to me. My Instagram, I think Mike posted earlier. I'll post my email in the chat, so you can feel free to reach out if there's any questions, or if you need help with anything else. I am generally quite available to answer questions.
Yeah. Well, thank you. And reminder to everyone, there's also a webinar Saturday and Sunday from us. So those are still open for registration. So go check that out. Thanks, Oscar.
Thank you, Mike. All right, everyone.
See you.
Have a nice continued rest of your day, and hopefully nice evening for those who are European side.
Yeah. See you.
See ya. Bye, everyone.